Very good morning, everyone. On behalf of IGEN and Panimalar Institute of Technology, I warmly welcome everyone for this 5th day of the Faculty Development Program on Renewable Energy. So, very good morning and warm welcome. So, we have already with a great energy, we have crossed 4 days. Today is the 5th day. I am sure, definitely, whatever may be the learnings which you have learned, you will be learning the application of all the energy with respect to the energy storage as well on day 5 today. So on behalf of IGEN and Panimalar Institute of Technology, I once again warmly welcome everyone. So let me go ahead with explaining what we are going to cover today, along with an introduction of what we have seen so far. Yes, here it is. On a day 5, as I told already, we have 5 days FTP on this renewable energy systems. As a part of that, today we are on the 5th day, that is the last day. Today we had a very interesting topic, that is other renewable energy, and of course that comes along with hybrid and energy storage. So today we have many eminent speakers. We have a chief guest, Dr. G. Pandian sir. He is joining from Indian Oil Corporation. Today we have, as usual, for all the 4 days, today also we have 4 different views. Today we are going to start with an employment view. We warmly welcome Engineer Yuvaraj M. He's a DGM at Schneider Electric, Chennai. He is interestingly, working in the microgrids, energy storage, and he has a vast experience in the renewables. So hope he will be able to throw quite a lot of light on what's the opportunities in respect to this renewable energy and specifically on energy storage. And we have Dr. P.S. Ramaprabha madam. She is a professor and head at Panimalar Institute of Technology. She is going to give an academic view of this Unit 5. And we have another eminent interesting speaker, Mr. P. Sivaguru. He is an energy storage expert. He is joining from Masdar Energy, Abu Dhabi. So he is going to talk about the industry view of Unit 5, that is other energy sources, and of course, more specifically on energy storage, microgrids, battery energy storage systems, etc. And finally, we have Dr. L. Ramesh. He is the dean at MGR and he is also a chairman of Green 9 and IGEN. So he is going to talk about the research view of Unit 5. So this is today's view. So let me quickly talk about the other views as well. Right. So on behalf of Panimalar and on behalf of IGEN, I again warmly welcome all the participants, those who have joined in Zoom or directly or live in YouTube Live. So I welcome all of you, in addition to the speakers and other organizers. So this is probably the overall view. We have talked with started with Unit 1, right? Means as I already discussed, we have always planned 4 views: academic view, industry view, employment view, and research view. Day 1, we have started with the inauguration from Sankar Narayanan sir from TEDA. Then Unit 1, that is Introduction to Renewable Energy, we have covered from academic view by Dr. Arunachalam from Saudi Arabia. And Balamurugan AE Tanjitko has given an industrial view, and Sindhil Kumar has given an employment view. And finally, Ramesh sir has concluded with the academic research view. That's on day 1. And day 2, we have focused more on the wind energy conversion system, where Sriraja Balaguru has talked about employment view, and Amuda from Power Projects has talked about industry view. Uma Shankar from Prince Sultana University, Saudi, he has covered on the academic view, and Dr. N. Amudan, professor and head Rajalakshmi Engineering College, he has talked about, he's from Rajeswari College of Engineering, he has talked about the research view. On 3rd day, we have talked about more interestingly on solar. The academic view was given by Dr. Selvi, professor and head Panimalar Engineering College. Industry view was given by Engineer Balakumar. He's a manager at engineering and design at Power Projects. Then I have thrown some light on the employment view of both wind and solar. And finally, on the day 3, research view has been given by Dr. Padmavati madam on solar. On day 4, yesterday, Mahendran sir from he's a professor. He has talked about the academic view, and industry view is given by Engineer Balaraman. He's talked about a little bit on simulations, Homer, etc. And the research view has been given by Dr. Mohanasundram, and I have talked a little bit on employment, more specifically what is the skill which the students and faculties has to develop to get at that employment opportunity. So that's what we have talked about, and we are at the day 5 and the final day as well. So we have, as I already discussed, we have eminent speakers. I'm not going to talk much more on that. So straight away I go with Lavanya madam to formally invite all the participants on behalf of Panimalar and IGEN and introduce the first speaker. Rama Prabhu madam.
Sir, very good morning to one and all present.
Yes, sir. Yes, madam.
Yes, sir. A hearty welcome and very good morning to all. The purpose of FDP is to replace the empty mind into an open one. I hope we have done so as our syllabus had told. We have completed successfully the 4 days of FDP and we are in the final day, that is the 5th day of the faculty development program organized by the Institution of Green Engineers, IGEN, and Panimalar Institute of Technology. On this honey-colored day, I am greatly privileged in introducing our first resource person, Engineer Yuvraj Muthy sir. He has about 15 years of experience in the field of energy automation, energy management, smart grid, and smart city domains. Currently, he is working as an associate general manager for power, energy, and utilities of Schneider Electric India. He specializes in the field of smart grid and smart cities, which is a need for the present urban challenges. He has presented multiple papers and delivered several lectures in the field of smart grid and microgrids. He has also worked with various energy automations and infrastructure companies. To name some of them are as solution architect in Harmonic Solutions, Baron Power India, as prescription manager, low voltage and medium voltage in Control and Switchgear India Solutions, as manager in technical marketing and projects, Ariva T&D Limited. And his last assignment is his work as an associate general manager, Central Technical Marketing, Schneider Electric India. Sir, indeed, it deemed a great privilege in welcoming you to share your valuable views on the employment opportunities of the other renewable energy systems. Sir, please. Sir.
Yeah, thanks a lot, madam. Before Yuvraj is starting his session, he's my close friend, so I'm just interrupting for a few announcements, which I forgot to make. The first announcement is still on. Means Sendil Kumar sir is directly joined us in Zoom and he's ensuring whether I am announcing that or not. So we have an award, provided or indicated from day 2 that we have a surprise cash award from IGEN as well as from Sendil Kumar sir. So because of quite a lot of requests to extend the dates and the many reports which we are receiving, we have increased from 1 prize to 3 prizes. That means you will get first prize, second prize, third prize for the surprise awards. And we have also extended the dates to submit the report till this Sunday. That is on 14th. That is coming Sunday evening up to 8 p.m. You can submit the reports. But we expect or we give a preference for the peoples, those who submit the report for all the 5 units. Which means even if you have submitted only 1 unit or 2 units earlier, still you have a chance. You can submit the report for all the 5 units. So the preference will be for the peoples, those who are giving for all the 5 units. And then probably we also look at the quality of the content. Thanks to IGEN and Sendil Kumar sir, we have increased the number of prizes from 1 to 3, and we have also extended the dates. And we have an upcoming program on internship where we will declare that first, second, third prizes, and the winners will directly get a call or directly will get a mail from igenfdp@gmail.com. So the participants, those who are joining live today here in Zoom or in YouTube, the choice is yours. You can prepare a report for all the 5 days and you can consolidate as a single report and you can submit it, or you can submit 5 different reports for 5 days. The choice is yours, but we are going to give a preference for the peoples, those who are going to submit, most number of units. That means the peoples, those who submit the report for all 5 units get a preference definitely over the peoples, those who are submitting report only for 4 units. And as what to say, Sendil sir has already stressed, we are going to give this for a first and second and third prize. That's the first announcement. And second announcement is yesterday also we have identified 3 active participants from YouTube, those who are already joining today with us directly in Zoom. First one is Asa. So she is assistant professor in EEE department in Hyderabad. We welcome you, madam, on behalf of IGEN and Panimalar directly joining us with Zoom. And we have Dr. V.V. Venkatesh. Dr. V. Venkatesh, he's a professor at Rajalakshmi Engineering College at the EEE department in Chennai. We welcome you, sir. And we have also an eminent research scholar, YSVV Venkatesh. He's a PG scholar in Andhra. So means based on their performance on yesterday YouTube chat and their active contribution, we have invited them to direct Zoom all the three participants. And in addition to that, there are other two speakers, those who have joined yesterday, Paul Raj and Sivachandran, they are already in. So means all our event of IGEN, we strongly believe that the event is for our participants and the participants are active contributors. So please join us, actively contribute today. Even if you contribute today, definitely we will catch you for the next upcoming programs for all the initiatives what IGEN and Power Projects is taking together. Right. Sorry for interrupting you, Yuvraj. I believe means what to say. I'm interrupting you and I'm consulting you. But anyway, hope now you can take it up. And to add a note, Yuvraj is an eminent speaker. He has about 2 decades of rich experience in industry. So Balraman, you can means what to say, invite the questions in YouTube. And as I told, like me, he will also able to take up the questions in between. So means what say you invite a question in the YouTube, and if there is any questions, probably with the permission of Yuvraj, we can interrupt him and we can post the question that adds a value. If that is fine for you, Yuvraj.
Yes, sure, Selva. No issue.
Yes, Yuvraj, you can go ahead.
Yeah, thank you, Selva. Good morning to everyone. Thanks for the
Yuvraj,
great
can
introduction.
you switch on your video?
No, I am totally been covered in mobile in my office.
Okay, fine.
So,
go ahead. No worries. Go ahead.
Yeah. So, good morning to everyone. Just want to check my audible. Am I audible?
You are perfect, Yuvraj. Go ahead.
Okay, fantastic. Okay. So, thank you so much, Selva, for introducing me, and as well as the ma'am has introduced me high about a lot of skill set, but I'm not so much so. But still, I can give some validation for this fantastic mm, employment review on the renewable energy. Just to introduce myself, my name is Yuvraj. I've been working in Schneider Electric, worked in different domains, worked in power quality, I can say power advising side, and then I worked in low voltage and medium voltage switch gears in other company, and then I worked in automation, smart grid, and then smart cities and microgrid now. So the introduction of myself is that I'm just moving from one domain to other domain to gain knowledge and work something challenging departments and segments. And today you could see that having one domain is not going to be suffice in the challenging environment. So you should be having all rounder. Today we have in most of the cricketer team, you could see that people of all rounders have survived much better than the people who are expertise in batting and bowling or sometimes in fielding. So having everything in one pocket is very important. So that is how the market is moving so dynamic. So it is like to gain all the departments, at least to understand what it is, how it is working, and to get some knowledge in different domain is very important today to talk about, because we are today talking about the employment view of renewable energy. What are the scopes metrics? What are the employment you will get in this renewable energy per se? So just to go on welcoming the audience, because I know a lot of audience would be joining, like students, professors, and then scholars. I think even the industrial experts in this session. I just welcome all. Thank you so much for connecting in this IGEN beautiful session. Thanks and appreciating IGEN. Then IGEN is doing a fantastic job. I'm closely associated with IGEN for a long time, and whenever they call us, I'll never say no to them, because they do lot of service to society. They're very open, down to earth. You don't know about IGEN. The people behind IGEN are more expertise, a lot of experience put across, not only in academics. They also have a lot of experience in industrial dynamics and upgradations. And it's, I think it's a fifth day today, and we are almost 4 days down now. A lot of information be shared by our eminent speakers, and the knowledgeable people behind the IGN have created the syllabus in such a way to cover up academic plus the industrial purview. So today is the fifth day, and thank you so much. I'm also a part of the fifth day to initiating this employment view of the renewable energy with a different perspective. Just to start with, you know about today is an unprecedented day. I just came to office with a lot of challenges, because I know I don't have a signal in my home. Last time I was totally disturbed on the signal issue. So I jumped into office with a lot of challenge. In this unprecedented situation, one thing has not been stopped so far. It is, do you know what is that? In the electrical perspective, it is renewable energy. So renewable energy connecting to the grid has not been stopped. It has not been curtailed. Even the thermal energy has been curtailed for some time, but renewable energy has not been curtailed to connect to the grid. This is a one thing which we should think of, that it is always on. An unprecedented situation, renewable energy has been plugged in 24/7 in the grid, not to disturb the renewable, because they know renewable energy will give you the sustainable solution in terms of the green, in terms of the cost effectiveness. It can use to stabilize the grid, and they can able to take care of the demand as well. So they understood what it is today. So in normal days, what happens, they will curtail the renewables in many times because of many reasons. I don't want to touch upon that. And today it has been very eminent that to say that renewables are on, very much on. And today we see about a new normal. We have been seeing many things in normal days, what we do in usual days. But today it is a new normal. We have seen a lot of learnings from the COVID, and the design of working, design of thinking is totally changed. I can say another way, when we always wake up, we always think about to send our kids to the school, and we talk about we have to go to the offices, and then we take the food lunch. If it's not possible, we go and take the foods outside, we'll manage the show. But today we are all being very peaceful with the family, and you could understand that the way I'm talking about in terms of being with the family. And we have a fear factor outside, but we have working inside the family, where the students, our own students, have been connecting in the internet, and taking the online classes. And today the IGEN is doing an online 5-day continuous class for the students. So the way of style is moving differently. And why I'm talking about this is, to tomorrow the employment review also will be changed. That's why I'm touching on this point. So we were been talking about unhealthiness of things, and today we're talking about healthy food, healthy environment. We need a good air, we need good food, good drinking water. This is how it has been moving on. So it has become a new normal. It is not the usual thing we thought about. This is totally changing the lifestyle of living things, like, even the living beings like animals, and people are coming out and enjoying. Animals are coming out enjoying in the environment. Even we are go back to the home, and we have been inside the home. All these living beings are coming out, like animals are coming out enjoying the environment. So you could see what sort of the living we are doing today. So total things are changed into new normal. And we have been talking about on technical for a long time, like greenhouse gas effect, CO2 emission, and we talk about net zero campus, sustainable, and so on and so forth. But for the almost 2 decades, or maybe a decades, we're talking and shouting for this. And today, when you talk about this unprecedented situation, all these points have been taken care, very, very important, because a lot of policy is going to change. I think most of the peoples of industrial people might know about this. A lot of policies in electrical side is going to change. In terms of Electricity Act 2003 is going to change, and tariffing style is going to change, and peak demand tariffing is going to change. Energy storage and new policy is going to come in. So the policy is going to change with respective on the greener side. And people are talking about net zero campus. I think most of people knows about net zero campus. All the industries, the campuses, or whatever you say, everyone wanted to use the green energy. They don't want to use the fossil energy. There is a lot of signatures happen on making the entire environment to net zero. Net zero means we're not going to depend on fossil fuels. We're going to depend on renewable side. That's it, called a net zero campus. And when you talk about net zero campus, and then it means that the entire campus is going to have a different distributed energy resources. We talk about in today's scenario. I think the entire environment is changing on electrical side. Any usage of power, maybe the energy I'm talking about, grid supply plus DG, you could see most of the time. But now today we're talking about grid plus DG plus solar. And I'm seeing a lot of projects are coming with CHP. People are coming with the fuel cells. People are going to coming with battery energy storage. The mix of energy is going to come in one premises, and you're going to work with all these energy resources tandem with it. And you're trying to reduce the grid power, grid in terms of the fossil fuels. You're going to reduce the grid power and trying to use all renewables, the green energy. So the battery energy storage, if you could see, it is going to be changed now, because we talk about battery energy is very costly those days, but now it is becoming cheaper. And then if you see the renewable energy of solar, the cost of the renewables of solar is very, very cost effective today. And one more thing is that diesel energy is going to be reduced because they're going to stop. Most of the states are going to stop the DG because it is not a friendly. It is the environment emission and environment crisis it creates on the DG because of the harmful gases of nitrogen oxide, sulfur dioxide, and maybe unburned hydrocarbons and carbon monoxide. So this is absolutely is going to change. The people try to stop DG in most of the states. It's going to happen very soon. And people try to use grid plus solar plus battery. This is the style going to change. And sometimes people have a CHP like combined heat and power, where you're going to have renewable through that CHPs, and then you're going to connect the fuel cells of hydrogen cells as well. So the change of usage of energy is going to change. That's what I just want to emphasize on this. And then battery storage energy, I think my colleague is also there in the second half to talk about that, but I just want to give some insight. Lithium ion price has been dropped almost in 10 years. 87% the price has dropped. The last 5 years it is 58% declined. In 2010 lithium ion price is 1160 USD per kilowatt hour. In 2019 the cost is reduced to 156 USD per kilowatt hour. You see the dip in 2010 to 2019. So then if you talk about the next 6 years, it will decline to 45 percentage from 2019 to the next 6 years. I could figure out 2025. The cost has become 94 USD per kilowatt hour. It means the battery price is going to reduce just like that is equal to the DG set which you're going to use it. So whatever the usage of DG in the market, it will be equal to the battery storage you're going to use it. So it is going to be a parallel pricing. The crossover is going to happen. So people will drop the DG, they will pick up the battery energy storage. And this battery energy storage is a part of the microgrid. So I'm emphasizing on this market analysis to understand this scenario. DG sets, we use it when the urgency and the when you want to use it for 4 hours or 2 hours, but it is a dumb box. You cannot able to play with the energy, and the cost of the energy of the DG, almost 14 rupees or maybe 14 to 19 rupees per kilowatt hour. So it is a costly affair, and then it is giving harmful gases. So in a battery storage, lithium ion, the price is reducing. It can play with the energy. It can give you a right ROI. You can use the energy 24/7. It plays in and out. It can give you time shift for the generated energy scheduling, grid stabilization, and peak shaving, and sale of power at a peak time arbitrage. So what I'm trying to insist here, the usage of energy resources have been changing, and the policies are going to support the usage of energy. And just to go on the recruitment style, I just leave this one and then moving into recruitment style. You've been seeing that we are not able to go to the office, but you're seeing a lot of news is that big shot of IT industries like Google and so on, they have recruited people, almost 500, 600 people in this situation in an online. There is an online test, and people go with an online interviews without seeing a one-to-one face. They have given almost a lot of employments through online. Okay, the employment is moving in that situation. And again I'm emphasizing on, because I'm going to talk about the employment view of the renewable energy. The way the dynamics happening in the renewable energy, I've spoke about that, but the other way around, the recruitment is also going to be changed. The process is going to change. So people are going to not going to see your knowledge, because there are people like students, professors, and experts are there, industrial experts. People not going to see your only the knowledge. People are going to see your intelligence as well. So people have so much of accumulants of knowledge, like 25 years, 20 years, 10 years of knowledge you have in different domain of solar, wind, or combine of both together, designing perspective of renewables. And then people have expertise in CHPs and designing and so on and so forth. They have a different knowledge of different segments of different arena. The point is, it is not the knowledge going to give you the employment. It's going to give you employment on intelligence. Knowledge is basically you accumulate the knowledge through the academic stuff, but the same academic you have to use in real time. Not only that, intelligence is nothing but using the knowledge at the right time in the right place, and using innovative solution. It's called the intelligence. So today company is going to see the intelligence people with the knowledge backup, and then They should use the knowledge in the right perspective to give a right solution to the market and the need. That's very important. Intelligence is the key importance to get the employment view on renewables, because for the past 2 decades we know a lot of employments happen in different segments of renewables. you know Solar has given a lot of employment, and if you see wind has given a lot of employment, and if you see CHPs or maybe different battery energy storage. But today need of the hour is combining all, okay, combining all renewables with the grid is going to be intelligence. How intelligently you are going to mix up this energy and reduce the energy cost, and you have to stabilize the grid as well. So you see that the two things, the knowledge comes in the grid stabilization, the intelligence comes in how effectively you're using the energy, the cost effectiveness. So you can use it. The grid stability, you have to manage the physical and stability. We talk about the grid stability where your knowledge comes into the picture, and the same stability comes in, you use the different resources and try to sell the energy to the grid, or bringing the energy back from the grid and using it internally. It talks about the intelligence. So you're going to use a mix up of energy, you need a intelligence. Same like that, your solutions, your knowledge should be given to the any of the firms in the renewable energy needs an intelligent how you're going to use the knowledge in different way. So automation makes a big impact on the renewables today. So if you think it's the conventional thought of renewables requirement will be happen, no, not at all. So you guys have to be very importantly thought about the intelligence of using the renewables. That's why I will touch upon the requirement style today. And then just to go back to give you some technical analysis, how this employment will be increased. This I can say in renewables, it will be more than 3 times what right now we are having the renewables requirement. It become 3 times will be in next 10 years. So it's become, if it is 100, the people need 300 people. In next 5 years, it can maybe more than that on the renewables. To have the analysis, why I'm saying this is the vision of India 2015, Paris Agreement climate, we are talking about Paris Climate Agreement 2050. It talks about 40% renewable should be there in 2013, 30, which connects with the grid. So whatever you generate, that should be 40% renewable in 2030. Okay. So this is what the Paris Climate Agreement is talking about, and India has been signed of so much of policies on that, and 175 gigawatt and so on and so forth. You know about that stuff, but I don't want to touch upon that. Today, RE integration is in the grid is almost 18 to 19 percentage into the grid, and 78 percentage is thermal mix. So 78 plus 19 percentage in the grid is renewable. This is today's scenario. And in 2030, that is on 2030, when you think about that, it is not imaginary stuff. It is the right figure, a precise figure, which is the demand which you're talking about. So 832 gigawatt is going to be generated. Okay, the need of the India on the energy we're talking about is 832 gigawatt, the power, and then in that 832 gigawatt, 291 gigawatt would be thermal. Okay, 291 is thermal, and then 17 gigawatt would be nuclear. So 17 gigawatt would be nuclear, and 523 gigawatt would be renewable. Okay, you could see that 832 gigawatt are the need of 2030. Out of that, 523 gigawatt would be renewable. In that, I'm adding in 523, 73 gigawatt is an hydro. It's inclusive of that. So I'm just making it as a round of figure of 523 renewable is required totally. So in 2030, if you could see, today the renewable integration is 18% to 19%, and 2030, 44 to 45 percentage would be renewable. Okay, and then in thermal energy, we're talking about the fossil fuels. 78 percentage is the thermal today, and then in 2030 it become 52 percentage. That is a decline in thermal. There is a big increase in renewable. So renewable become 44 percentage in 2030, and thermal become 52 percentage in 2030. So solar covers 3 percentage today. Solar covers 3 percentage today's environment, which you're talking about. Energy is 3 percentage total gigawatt. I think approximately 360, 365 gigawatt we generate today. In the out of the 3 percentage solar, and 2030 the solar become 23 percentage. You cannot able to imagine. In 2030, 23% would be the solar. Okay, it means 300 gigawatt would be solar in 2030. So you see that changeover is happening today. The 2030 design We are marching into 2030. So 40% renewable, and the thermal energy is going to reduce, the solar going to increase, and now the battery storage is coming into picture, and then a lot of mixing of renewable energy, and people try to come out of the thermal, try to use the green energy. There will be laws in green energy, lot of incentives for the green energy. So people think about the sustainability. So things are moving in a different direction today. So you should not forget this. So this point is to check why I'm talking about this. Then the tenders. We have to talk about the tenders, what is happening today, because that is an authenticate stuff which gives you more insight to you. Because you have to trust what I'm saying, because that gives you more focus to you and more visions to you. The tenders are coming up in utilities of I think in last 4 days it have been spoken about that. HARI plus storage, renewable energy plus storage, a lot of hybrids talking about solar plus wind, and solar plus wind plus battery. Sometimes they say round the clock tenders. Round the clock, you have to give the energy to the utilities with the usage of battery energy storage. As I told you, that battery storage, the battery pricing is reducing drastically. People surely will go for a battery because it gives you a more energy effectiveness, and it plays in the grid and gives you a lot of ROE. So that's how the tenders are going on. Lot of tenders, 1,200 megawatt, 500 megawatts. So many tenders are coming up. Almost 10 to 12 tenders are coming with the storage. The combination of solar and wind and battery storage has been plugged into the tendering, and style of usage of energy is also changing. A lot of policies, SECI is a lot of coming, a lot of tenders, and CRC coming, a lot of policies. CA giving a lot of predictions on doing that. POSCO, I just want to touch upon POSCO. POSCO is coming out a lot of tenders with HARI MC. You know about the integration of renewables with the grid, like utilities. There is a central government pushing the REMC. It is automation, which gives you more visibility how to connect the renewables into the utilities. REMC tenders are coming up. Almost 10 to 11 tenders are there. REMCs in utilities. So when you see and touch upon everywhere, the renewables are coming into the right time and limelight to the renewables. People are talking about how to mix it, how to use it. Now the intelligence comes in. And there is one more topic I just want to touch upon. That is a DREMS software, Distributed Energy Resource Management System. This is the DREMS software is like a software of a smart grid which you use it. DREMS is the software which has been connecting all the renewables, and it connects to the smart grid of ADMS and OMS. So ADMS, OMS, and DREMS connect together. ADMS talks about the network management of the grid. It gives you grid stability in terms of volt and var and all the networking stuff. And OM as an outage management system and reducing the SIFI and SIDs and so on and so forth. With that smart grid, this DREMS software is going to connect. So DREMS is nothing but to connecting the renewable into the smart grid side. So everything is changing. The whole look of the design changing is totally different. So now we see what is the employment. Now you have to tell me, does the employment will be there for renewables in terms of hybrid or solar wind of combination? So now I'm giving the question back to you. After this of a discussion, do you don't think that the employment is going to be increasing our renewables? And what sort of the intelligence you need to get into the renewable sector? What do you need? What are the companies are there? Are you already been into the knowledge perspective? You have that acumen of renewables. That is a question again. There are people, so much of knowledge, people are there already in the sector, but what the lacuna, what they have, what is a gap which they see in this renewable segment is that the automation. People knows about the conventional solar. People erect the solar, they design the solar panels, they know what is output, what is the efficiency of the solar, and how to connect the distributed solars, how to see the performance of solar, how to see the asset of the solar panels. So how to connect the solars into the grid. So how to have a common dashboard for the solar grid and other renewables. Can I able to curtail the PV? Can I see from the remote which solar panel has been disconnected? Is it disconnected because of any manual fault, electrical fault? How do I see this? So this sort of the intelligence is missing. So the automation makes a big difference on the conventional employment view, and then the intelligent employment view is something different. So when you think that I am good in this in terms of different view of understanding of automation, I can say it's out of the box thinking. Normally, when you think about the conventional way of employment search, you will have not getting these right opportunities. So if you want to think in out of the box, then your doors are open. So just to see that into this, what are the project people, project developers, or maybe the EPCs into the market? I just want to give you some names of that. That gives you some insight about it, so that what are the companies, because every time when we speak, people say, what are the companies, tell me the companies, do they have employment, and some people may ask, students are there. I just touch upon students. So students from the electrical perspective, or maybe electronic perspective, or the mechanical engineers wanted to go to the renewables, and what are the documents we need. I think the 4 days there was a lot of sessions happen, and you have gained a lot of knowledge about it. The students, what we see, you should know the basics, very important, how to design and so on and so forth, the basics I'm talking about. But the basics of the automation is also important. I think yesterday I think Silva has given you automation, how to create a microgrid, or maybe Silva was talking about that. These type of softwares are going to be a very important role in renewables. It's a vital move of the renewables. There is a separate employment for the people who knows the software handling, not only on the design, it also the interconnecting of the renewables with a one bus, and then as well as the asset management of that, and then the designing in terms of sizing of the battery storage, and how to use it to grid stability and so on. So power system concept plus the designing of the hybrid has become more vital today. And plus today we're talking about asset management as well. So there are so many companies today in the field. I could able to see there are Havada, Renew, and then Tata Power, Azure, Sharpunji Polanji, and then you can Jackson Power. You can talk about, and lot of project developers like Greenco and Renew has taken a very big project of hybrid one. And we talk about SB Energy, Hero Future, and Maitra, and then Adani. Adani is doing fantastically on renewables. He has taken a separate team for renewables. A lot of empowerment is happening with Adani and Greenco, and then Renew. They are thinking about the hybrid concept of renewables. And when you touch upon the battery energy storage, this is again, I just want, before going to battery energy storage, I want to talk about many things, and can I go? Now, when you talk about solar, it is not only the solar. In the solar, the panel designing, in terms of the inverters procurement companies, a lot of inverters manufacturers will also need your support in terms of designing it, inverter designing, and then from solar panels, and then assert of the solars, how to make the assert of the solar. And then moreover, when you talk about um, the wind side, a wind generator, like a lot of companies of Vestas and Axiona. So many companies are there in the wind side. So these are the different companies we talks about, not only in wind and solar, and CHP, a lot of companies are there. And then battery storage, when you talk about, Laclantia, Excite is created a separate wing for battery storage in Laclantia. It is a German collaboration. They are a manufacturing plant in Gujarat. They are manufacturing the battery energy storage. I'm not talking about the kilowatt size, it's a megawatt size. And before touching this battery storage, I have to give one information that lot of projects have come out. I think Selva can vouch on it. If you see Tata Power, TTPBL is doing 4 projects. One has already been done with the AES, with the combination of Siemens Intelligence. 10 megawatt battery energy storage. It's not kilowatt, 10 megawatt. It's used for the frequency stabilization and voltage stabilization, energy arbitrage. So this has been done, and already is there. It has been said. And Pondicherry, there is about I think a 500 kilowatt battery energy storage done by the different vendor. It's already there in the Pondicherry. And then if you talk about same Tata Power, we are doing one microgrid solution. Microgrid solution, we are doing it in Tata Power. Schneider is doing there, and then Nexer is doing one pilot project there. And then BSES Rajdhani, the utility BSES Rajdhani, it's in the north side. Rajdhani has come out with a tender for battery plus grid combination usage. What they're doing is they're charging the battery on the off peak time and discharging in the peak time to work in the peak shaving side. There is a tender in BSES Yamuna utility, same with the grid plus battery plus the solar stuff. So again, Terry has come out with a tender. So many tenders I'm talking about. Many tenders are coming in battery storage. So Leclanche, like Exide, and then Amar Raja is having a battery storage device, and then Sterling Wilson today, I think people have been spoken about that. L&T is having a separate team for battery storage and renewables, and then Panasonic has come out of battery storage, and Aero Future, and Okaya, Statcon, TBA, Sustain Mahindra, and then BEL, BHEL have a separate as a government entity I'm talking about, and SunSource Energy. So many are there. I can name it because Selva is telling that can you give me some companies? So many companies are there in different domains. The point is, when you talk about this wind and solar and so on and so forth, there is a one more vacancy in the consultancy. I think Selva is doing a lot of consultancy. He can also give me more insight about it. Every consultancy has opened a separate wing for renewables. It has happened last 6 months before. A lot of big consultancy like Tata Consultant Engineering has started a separate wing for renewable energy for battery storage, and Fictioner has started as a new separate wing for energy in terms of energy storage and renewables integration. And Tractable has come out with a separate wing. Any consultancy, if you go and touch, there is a separate wing started for energy storage and renewables because they know the project is going to be come up. The design need is there for consultancy. So just to give you the restatement of, or maybe you can rethink in such a way that anywhere you go, you will get this requirement of renewable understanding and acumen of knowledge. And moreover, just to give you some insight of microgrid, people talk about micro means very minimum, and people forget about that. People don't take importance of the microgrid. It is not a microgrid doesn't mean it's the size of the project of micro. It's a reinstate in the other way. You have to see the micro level of energy usage. That is what I think it's a micro. Because today microgrid, those days of 10 years before, people talk about kilowatt size of a microgrid. People will talk about megawatt size of a microgrid, and people even talk about 50 megawatt and above in microgrid. So microgrid name has to be changed now. That's what I feel today because the thought of a microgrid 10 years before, it's now it has been changing literally. The thinking about the microgrid is totally changed. In the microgrid, as I said, microgrid is nothing but managing the distributed energy resources to enhance the grid stability and gives you the economic sizing of the energy, and as well as it can be connected to the grid or disconnected from the grid, isolated mode. Sometimes it can be connected to the battery, or many a times it cannot be with the battery. So microgrid is the managing the distributed energy resources in one site. Okay, so in microgrid there are so many people. In terms of microgrid, I'm talking about the automation part. I can say the person who gives intelligence to the integration of all this. There are many companies like we are from Standard Electric. We have a separate team globally, and there are two R&D centers. One is in France and one is in Singapore, and we are trying to make it in India as well. So R&D team is going to be for separately for renewables for microgrid. And then I know, I think ABB is there, and then Siemens are there. Siemens is playing a very vital role in those renewables now. And then so many companies are there. G is there, SNC is there, Green Empowerment, and Tesla. So many people are there in the microgrid perspective. So if you could talk about even G is also having some microgrid solutions, and Socomec is also having in globally, but not in India so much. But these are the companies. Even Caterpillar are also having a solution in microgrid globally, and Johnson Controls. You may be surprised about that. Even they do also have a solution in microgrid. So when you talk about many companies in India, we could see Nari is also competing in many places, and if you see Honeywell is also having some solutions in other places, and EDF is a French base, but they do a lot of pilots in India, and SMA. So many companies across. I can name it many companies. If you want, I can make a separate list and show to you. The point is, you have a requirement in solar, wind, and so on and so forth. The point is, who has the intelligence to connect all energy resources and give a right output? That would be the real game changer for this employment view in renewable energy resources. And just to close, before closing this, I just want to give one of the insight. It is not only the automation of microgrid. In the microgrid solutions of hybrid RE, There is two things which is playing very vital today. One is the artificial intelligence. Our softwares are having artificial intelligence, so people who have the knowledge and artificial intelligence also been welcome and have a creamy welcome of the requirement, because artificial intelligence is elite usage of the energy today in the microgrid. As well as there is one more surprising thing to you is a blockchain. So blockchain is going to be coming into the energy sectors for REs as well. Blockchains give you a very safety, reliable in terms of the renewable, in terms of the billing and so on and so forth. It is a fantastic solution which most of the utilities are trying to adopt this blockchain and artificial intelligence. We also have a separate team for that to work on this AI and blockchain as well. So when you see this top view, I can make a segregation. People who knows the intelligence and automation like AI and blockchain, and coming into the normal automations of power systems, SCADA, and then people talk about the asset management of the all these renewables, and people knows about how to connect this all in terms of the connected products. People know about intelligence and knowledge and connecting the products in terms of the inverters connected in the solar, and the wind side you have intelligence, as well as to connecting the wind, and the DG side the connections we got the controller, and then you talk about CHP controller in terms of and then the gas turbine fuel cells. All these intelligence hardcore components you should know about it. The working style of the principles and designing of it is very important. The point is the connected products, you should know about it, how to design it, what product should be placed in connected, because unless until the connected products is not speaking to the next layer, it means, yeah, the inverter should have the protocol to speak to the HMI, the SCADA. Otherwise you cannot curtail the PV, you cannot understand to take the inputs from the PV, and you cannot show it in HMI. So there should be intelligence on the connected products. So you should know what is the PCS, how it works with the tandem with the PV side, the input and output side, how it's stabilizing, what are the futures you have, what is the protocols you can do it, what are the information you can plug from the field, and you can moving it to the HMI, the top layer. It's very important. So connected layers like PCS, wind turbines, how it is speaking to the HMI. Every segment has a different software. Solar have a different software, and wind has a separate software, and then you have a different software to manage remotely. The point is, do we have able to connect everything in one HMI is going to be the real challenging. So you guys have to be more intelligence on the connected products first of all, how it's speaking to the next layer, and second layer we talk about edge control. We talk about the taking a decision from the edge control. You want to curtail it, stop it, on and off. That is called edge control. We call the decision making software like power SCADAs, where we should be have intelligence on that. But normal SCADA, I've been worked in substation SCADA, but renewable integration SCADAs are so totally different because the topology engines have been incorporated in renewable based SCADA. So both are same, but there would be a small changes on when you connect the renewables, it automatically takes the inputs because the topologies and the isographics are already been inbuilt in this SCADA software. So that is called edge control. So you guys, there are three levels of recruitment will happen in renewables. One is the connected product side, hardcore environment in terms of I'm electrical engineer. When I came out of electrical, I said I will only work in electrical. I will not go for the IT side because I love electrical. The point after I came in, after 5 to 8 years down the line, I could see the market is moving into the automation perspective, and people want to see remotely what is the transformer winding temperature and transformer oil temperature. People remotely change over the tappings as well, and the people remotely see my transformer, and even the fat test, the factory acceptance test, when we do a site test, it's happening remote today. High fat we talk about. So everything is changing into automation, and remote connections are being connected today. So the people who loves hardcore side, please move on to connecting the hardcore intelligence and knowledge to the automation perspective, how it has been connected. So that is why I'm talking about today. One is the connected products. Who loves the connected? Be connected. Keep the knowledge with that, and top of it, connect your intelligence like automation like SCADA. And again, the top of it, there is a one more layer called apps and analytics. Apps and analytics is that there is a separate software like advisory software. It takes the input from the SCADA, it gives you the real informations on the top layer, like the CEO, CXO level of the companies will see this intelligence from the top view in terms of advisory layer, what happening in the field, in the connected products. You can see very clearly with the beautiful charts and analytics in the top layer. That is called apps analytics. It can be today coming in a mobile, you can see it in mobile, you get an SMS from that, and you will have a different engines on the advisory layer. You can sell the power outside, you can bring the power inside, you can participate in demand response in the utility. You can also have weather forecasting. You will also have asset management in the apps analytics, the top layer. So you should not come from the bottom to top. If you want to be more intelligent, come from top to bottom. Apps analytic, and then your edge control layer in terms of the controlling layer, and then the connected products. I know all the students and professors and scholars all have a very good intelligence on the connected products, because we've been taught in such a way for the more than 5 decades about the hardcore principles, how these hardcore connected components work together. But the point is, we have not been taught that how these connected products can speak to the other layer. This is the lacuna, or this the gap which you get in most of the academics. So you should think how this product can speak, how this product can give you life, how this product can increase the lifespan by understanding the temperature and pressure into it. That is what today we are talking about. Those days we fit the transformers, we forget it off for 30-40 years. At the efficiency, we don't know what is output, what is the loss, we don't know, we fit and forget. But today, most of the countries connecting thousands of transformer asset management, they can remotely see what is the efficiency of the transformer. They even see what is the temperature, is it giving the right output, the right loading. Everything can be seen in a one dashboard. Even 10,000 transformers are connected in a one HMI, they are seeing it in asset management. So people are totally changing. So you guys should think about knowledge perseverance. That's how I can finish it today. Be strong in knowledge, and you try to take information and learn information on the intelligent part of the knowledge. That's what's very important on the employment view of renewable energy. That's all from my side. Sendil, if anything, Silva, if anything is there on the question perspective, we can talk about that.
Yeah, thanks a lot, Yuvraj. There are, I mean, so to say, quite a lot of interesting discussion which is going on in YouTube. And means very quite interestingly, one of your classmate means he has found out you in this. I will share his contact number probably after this session. You can directly call him and catch him.
Okay.
So he is Mr. Valava Madhu. Okay, I will share his contact number. Okay, fine. That's great. Even that same thing has happened some 2 days back. When means what to say, Balakumar was presenting, he was able to find out his classmate in YouTube. He has commented. I think this session is not only communicating some technical message, but also bringing back the old memories and relationships. That's great. I want to stress one important aspect. Means you have told this consulting services exclusively for this renewables and microgrids. You have told many companies like TCE, Fishner, Tractable, and means what do you say? I have to probably say that means Power Projects has identified.
Yeah. No, Silva, I've told yours that. I told that before starting this. Silva is also doing consultancy.
Okay, fine. So means what say, we have identified this potential, and we are doing this for the means much more years, like almost 5 years. And all these companies has means what say taken up our resources, and now they have started the business. Okay,
I know, Selva. I know that.
That's great. Okay, fine. Now means what say Bala can go with the questions in the YouTube. Balraman, please.
Yes, sir. Yeah. So thanks for the brainstorming session, sir. So we have a question. So normally when we go for conventional plants, the number of people we employ will be higher when you compare it with solar and wind farm. Then how we can say it is going to fetch a job for them? When you move to renewable energy, how we can say it's going to fetch a job for them?
Fantastic question, actually. So people always think that it is a 10 years old question. People always have that. When I came out of the college, this is the same question again. Today also same question coming up. But when I see comparing from the 10 years back and today also, so the difference on YTD, if you see, the employment has not been reduced or shrunken because of the automation. The employment has increased because when you see the automation need is, it's, I can say 4 times or 5 times. Okay. Automation, I'm talking about the automation perspective. People say if I become automation, nobody is required to do that. So why this employment is increasing? Everywhere the automation coming in, okay, there would be a crossover happen. Everything is become an automation. That is not, we are not in that mood at all. We are not even started. We have not started an automation. I can say in that way in India. And we have so much of employment in the next 25 years, I can say. When there is a crossover happen, everything is become automation. Then you can take this question. I can give the answer for that. But we have so much of leverage in terms of the 25 years to 30 years. We have not even started automation. We don't know the definition of automation. We don't know what is the definition of smart grid. We don't know what is the usage of all this automation. Till now, we don't know the real definition, how to use it, what is automation. I can vouch, even Silva can take this answer, because we were talking about microgrid for a long time, of hybrid or a battery and connecting this. People don't know how to make it. Even Selva has designed so many projects, and his knowledge and the people who have a high-end knowledge cannot able to match, because Selva have experience on real-time basis. He's been working in the real-time requirement of the automation. He knows the designing of it. And people who talks about I have an experience of 25 years cannot able to match, because they are not connected to the intelligence of it. And people should accept a down to earth openness and try to learn the intelligence. The automation need and the requirement is plenty, and there is a time of 25 years. Let after 25 years happen, if the same question comes in again, I don't know, I can give the same answer to India. This question, if you ask in other countries, even they have an opportunities for the automation. There is no shrink of making it. The manufacturing of transformer, if you could see, the need of the transformers are the hardcore, I can say, because why I'm taking the transformer, there are so many people on electrical. Manufacturing of transformer is now being increased because the demand is increased. And the design of the transformer is now increasing. The demand, renewable based transformers are coming in, and asset based transformers are coming in. A new design of transformer, we were talking about the core and the stuff, the oil. We're talking about today, the oil is totally different. It's not a mineral oil, it's vegetable oil we're talking about. Tomorrow, the technology will change. The design of the physical is changing, and that also need a people to think about it. And manufacturing that new design, we need a different people, and connecting it to the remote as a different team. So if you could see segmentizing the manufacturing of transformer, the people who does the normal designing of the transformer in terms of design is changing, and then the usage of the transformer, the demand is increasing. So the environment, the employment is going to increase. And then the technology of the transformer is changing. As I said, today the oil is changed, the cores and the ions have been changed in that. And then if you talk about the oil is in renewable based green based oil. And then we talk about your oil LTC remote, everything is remotely controlled, and you can see they are certain remote. So you see different employment and different phases of making the transformer. So it is not that it's shrinking it, it is developing the employment. And India, this will be having a huge scope of employment. It is not shrinking. So that's the answer for you. After 25 years, if you ask this, I may give the same answer, because we are not using the automation and we are not fulfilling the gap. In other countries, everything is changed in automation. They are trying to crossover means, as you said, the employment reducing because of automation. Even the other countries who is very niche on the automation, still the employment is increasing. Then how do you say India is going to cripple this employment? No, not at all.
Thanks a lot, Yuvraj. That's really a good information. So many people think that when automation comes in or renewable comes in, the job is coming down. Answer is no. Instead, it is increasing. They are probably not looking at the holistic view. That means, the example, how they are comparing the opportunities, like 500 megawatt thermal plant means, what to say, there will be 100 people or 150 people in operation maintenance, but means, what to say, in a solar plant of 500 megawatt, only 4 people. That's what they compare. But the comparison has to be in the other way around. Means, what are the products which are manufactured, what are the automation goes in, how many design companies has grown. So means they have to look at the total complete picture. That might be the means, what they are not able to see the complete picture. That might be this question, but beautiful answer, Yuvraj. Now I have to personally thank you for joining and sharing a wonderful session. And this is also an information for the participants, those who are joining. So they thought that we are seeing the slides and talking, and even there are a few comments I could say that the slide is not changing. But so he has not put up any slide. Only just name will come. So I have shared his photo along with some image. Okay, he was talking without any slides. So that's his potential. Only thing what I can say out of this session is, like, if you have a potential, getting a job or starting a new company or becoming a freelancer is not a difficult call. Thanks a lot, Yuvraj. Now I am going. Yeah, yes, Yuvraj.
Sorry, Selva. Just to give you closing, because you touched that point, so I just want to close that point. So today we have been working in a company, like a bigger company of MNCs, and Selva came out of the big experience of a big MNCs, and he is working separately, showing his acumen of knowledge. And same, I'm just saying to all these people who has joined here, You can be alone as an entrepreneur. You can able to make yourself as a startup, because we company like Schneider is connected 150 startups which connected in Schneider. I can vouch ABB is also connected a lot of startups, and Siemens Mindsphere is also one of the startup. So all these MNCs are connecting, giving opportunity to startups who has a different domain expertise of intelligence. So there is a big vacancy, requirement is happening for MNC. If you show your different intelligence on different perspective, there is a great opportunity. That's what I want to close. Selva, you just about touch that point. Thank you.
Thanks, sir. Thanks a lot, Yuvraj. Now I am going to Jones for takeaways.
Thanks, Selva. Thank you.
Thank you,
Thank you,
Yuvraj.
sir.
Thank you, Yuvraj.
Thank you, sir. Thank you for your very much for your eye-opening session on renewable energy. Your session was very informative. From your session, we take away that knowledge doesn't matter high, whereas the intelligence matter high in employment. Seeking in the conventional way won't provide new opportunities. We want to think out of the box. There are a lot of opportunities on integrating standalone generation with the grid, and on the automation on several stages from generation to distribution. The data which you provided, like in 2030, out of 832 gigawatts, 523 gigawatts will be from renewable energy, and the solar energy level will be moved from 3% to 23%. Shows that there are a lot of employment opportunities in the renewable energy, and also the microgrid is also an area where we can get the greater opportunities. On the whole, those who have an intelligence in hybrid system, interconnecting on grid automation will a real game changer in the future years. In the next few decades, renewable energy will rule the world in power generation, and also we get a clean energy and a green environment. Once again, on behalf of Panimalar Institute of Technology and IGEN, I thank you, sir. Thank you very much.
Thank
you
you.
so much.
Yeah, thanks, Yuvraj. Thanks, Jones. Now, before I'm going to Lavanya Madam to introduce the next speaker, I will go with an announcement. I'm just repeating this announcement because that's important from 2 or 3 perspectives. One is the individuals can grow on their own, and that also fetch quite a lot of means knowledge to IGEN, Panimalar, and of course that would be an evidence record for the future. Right, there is an interesting case award. As long as till yesterday we have communicated that only 1 award, but that we have increased to 3 awards. But Sendil Kumar sir is joining us in Zoom, and he's ensuring that whether I am announcing it or not. So we have 3 case awards: award 1, 2, 3, and that is for the peoples those who are submitting a report on a daily basis or a consolidated report for all the 5 days. But please understand, the preference will be given for the peoples those who submit for all the 5 days. So kindly ensure that you are sending the reports, and the submission for the dates which we have announced 8 p.m. yesterday, that has been extended to 8 p.m. on Sunday, that is 14th June. So I mean, ensure that you are sending the reports for all the 5 days before 14th June, that is on Sunday at 8 p.m. The email ID, I believe, already be shared. Probably we will try to share that email ID. I mean, it's quite few times again in YouTube chat. So kindly ensure that, and the winners will be directly communicated, and we will be announcing the winners in the next program. So that's the first information. And as I already told, there are 3 speakers, the 3 participants yesterday, those who are active in YouTube. Today they are brought in inside. So be active in YouTube today. Also, we will ensure that you are becoming a participant or a speaker in our upcoming days. With that quick announcement, I am going to Lavanya Madam for the inviting and introducing the next speaker. Lavanya Madam.
Yes, sir. Sure, sir. As the saying goes, in learning you will teach, and in teaching you will learn. I hope our FDP organized by IGEN and Panimalar Institute of Technology helps to gain both learning and teaching aspects of renewable energy systems. Our next speaker is Dr. P.S. Ramaprabha Madam. She is the HOD EEE Department of Panimalar Institute of Technology. She is a graduate engineer in EEE from SRM Ishwari Engineering College in the year 2000. She obtained a master's and PhD degree in Satyabama University. She has about 20 years of teaching experience with 12 years of research experience. Her research interest includes image processing, medical imaging, embedded IoT, and renewable energy. She has accomplished a groundbreaking research on early diagnosis of cervical cancer using coloscope images. This astute research has brought her to the pride of owning doctorate in engineering and biotechnology. She has jubilantly participated in numerous national and international conferences conducted by reputed journals and published many papers. She is also a member of IEEE, ISTE, IETE, and IEI. She has received Outstanding Woman and Young Woman Scientist Award. Ma'am, I welcome you to give your academic view of Unit 5 in Renewable Energy Systems.
Thank you very much, ma'am, for your introduction. A warm good evening to all gathered here. Today I'm going to talk about the Renewable Energy System, EE8703. Today is the 5th day of this FTP program. And this EE8703 Renewable Energy System, 4 units are covered by other eminent speakers. Today I'm going to take about the Unit 5, other energy sources. And that other energy sources, let us see the syllabus. Let us see the syllabus of the Unit 5, which consists of tidal energy and wave energy and ocean energy and ocean thermal energy and hydro production and storage cells and its working and various type constructions, energy storage system, hybrid energy storage systems. Let us see the energy from the sea. So actually energy from the sea are divided into 3 categories. The first one is tidal, and second one is a wave, and third one is the ocean thermal energy conversions. Let us see about the tidal energy. What are the content we're going to cover is what tidal energy and types of tidal power plant and classification of tidal energy, Indian tidal energy and advantages, limitations. Let's see the tidal energy definitions. The tidal energy is defined as the energy that results of moon and the sun gravitational influence on the ocean. Height difference between the height and the low tide create a tidal current coastal area, and the current can be strong enough to drive the turbine. See, let us see what is the tidal energy. See, a tidal energy, we know a tide is getting away from the sea tides, the daily rise and fall of ocean levels. So it's relative to the coastline. As a result of gravitational force of the moon and the sun, as well as the earth. So when the earth, moon, and the sun positions in a straight line, the gravitational attractions are combined, resulting in a very high tide, that is a spring. At a half moon, a sun and the moon are right angles, so resulting a low tide. It's called the neap tides. In order to produce a practical amount of power, a difference between the high tide and low tide, at least of the 5 meters, is required. And this is what is a high tide, and this is a low tide pictorial representations. We can see that there's a full spring and the third quarter of that neap, and again full or a new spring. Per day, we'll be having a 2 full tide, and that is full tide, high tide, and 2 low tide, we are going to get it. So let us see the types of tidal power plant. See, we have 2 types of power plants. One is a barrage, another one is a non-barrage. Let's see the barrage type 1. See, in that, how the electricity is generated. See, a dam is constructed in such a way that a basin gets separated from a sea, and a difference in the water level is obtained between the basin and the sea. The constructed basin is filled during the high tide and emptied during the low. So tide passing through the tunnel called the sluice and the turbine. And the potential energy of the water stored in the basin is used to drive the turbine, which in turn generates the electricity as it directly coupled with a generator. And based upon the basin, we can classify our tidal power into two. One is a single basin tidal power, another one is a double tidal power plant. Let us see about the single basin tidal power. See, before going to the single basin tidal power, we have to know about the flood tide and ebb tide. So what is flood and what is ebb in the sense? Flood tide, what comes from the sea to the land, and the ebb tide is water goes towards the sea from the land. Yeah, actually, what is a barrage in the sense a dam is constructed, dam or barrage which is constructed in between the sea, so that the function of the barrage is to form the barrier in between the sea and the reservoir. We can call it a reservoir or as a basin. Okay. And next, when you see for the single basin tower, it's actually a power determinantly. The basin, the dam is in between constructed between the sea and the basin, and rise and fall of the provide the potential head. And next, this is a pictorial representation of the dam, and we have turbine with that. And whenever we are getting the high tide, the water as from the sea, whenever we are getting the high tide, the water will enter into the basin. This is a pictorial representation of the low tide stored water flows out from the reservoir. Okay, and this is a pictorial representation of the high tide water flows from the sea into a reservoir. And that time, this turbine will be acting as actually water is having the high potential. So due to that potential, the turbine rotates and the water will be coming from the sea to the during the high tide enters into the basin or the reservoir. And during the low tide, the water will be from the basin to the sea. This is another pictorial representation. A sluice. This is a sluice gate, and which can be opened for the during a high tide level. It will be opened and the water is entered into the basin, and again for this, and which will be closed. And then during the low tide, again the water from the reservoir will be entered into the sea again. So there's a turbine which will be rotate to generate the power. This is a cross-sectional view of the dam. You can see the high tide level and the low tide level, which is actually in terms of the be 5 meters should be there. And next we'll move on to the double basin tidal power plant. And there's a double basin tidal power plant. We have two basins, that is two basins will be there, and between these two basins will be having a powerhouse will be mounted, and this lower basin will be always constructed in terms of the lower level, and thus will be having the sluice gate in sea to the upper basin, and there's again sluice gate will be there in lower basin. And this lower basin always in a lower level. You see. And next, whenever we are getting the high tide, the water entered into the high basin, high reservoir, and which in turns, due to the high potential, which in turn will rotate the turbine, the water is entered into the lower basin, and then after that lower basin, filled, the water from the lower basin will be entered into the sea. This is what is the construction and working principle of the double basin tidal power. Actually, avoids the limitation of the single basins, and here we have a continuous on demand basis the power will be produced and consists of this. And here, see, we can generate the power continuously. Whenever the high tide comes, we'll be getting the water inside the barrage, and then after that there is basin, and after that in a lower basin, it will be filled, and then it will it is coming back to the sea. And next we will move on to the next slide. That is a power generator. Energy available from a battery is dependent on the volume of.
Sorry to interrupt. You can switch off your camera. Slightly voice clarity we are losing. So you can switch off your camera and you can go ahead. Yes, madam.
Okay,
Perfect, madam.
okay.
Perfect. Now you can go ahead, madam.
Okay, okay. Yeah. Okay, now it's okay, sir?
Yeah, yes, madam. Now we are hearing. Yes, madam. Yes, madam.
Yeah, okay. The energy available from the barrage is depending upon the volume of the water. So this is a formula for that. And the difference between the sea level of the high tide and the low tide has to be calculated. That is a Z1 and Z2. This is a formula rho G into CdA, square root of 2G into Z1 minus Z2, the whole cube. And here the discharge coefficient, CD is the discharge coefficient, A is a cross-sectional area in meter square, G is a gravity, and rho is a density. Here the discharge coefficient accounts for the destructive effect of the flow passages. This is a formula for the energy generator. And next we'll see the Indian tidal energy. Tidal energy is one of the new and emerging technologies not available still in research and development stage. India has a long and coastline with the Eschusen's curve where the tides are strong enough to move the turbine for electrical power generation. Indian tidal energy, which is saying a lot of research are going on in the India tidal energy. We'll see the advantages of the tidal power plants. We have a large area of the valuable land not required, independent on rain and uncertainty. Peak power demand can be effectively met when works with the thermal or hydroelectric power plants, pollution free. And when we see the limitations of the tidal power plant, the output is not uniform. The plant efficiency is affected because the turbine have to work on wind range of the head variations. Factor of machinery being incorporated due to corrosive sea water, difficult to construct, costly, high transmission cost. Let us see the video clippings of the tidal energy for the understanding.
Tidal energy.
Madam, it's not clear, madam. Probably you can go to the next slide. When you're
Okay.
playing video, yes, clear.
It's not clear, sir?
Yes, madam. When you are playing a video, I think because of low bandwidth, we are not able to hear. You can probably go ahead with another slides.
Okay, sir. Next we'll the wave energy. A wave energy is a regular and oscillating low frequency energy, a source that can be converted to a 60 Hertz frequency and can then be added to the electrical utility grid. And actually, I have to play the video just to, as no need of volume. This video. Just look at this video, you'll be getting the idea of what the wave energy.
Madam, I think video you may not be able to play with your bandwidth. You can probably go ahead with the slides, madam.
where the best, we'll see next we'll see about the slides, where the best waves will be getting it. In generally in extreme latitude and west coast of continent, will be view the global wave atlas. And the another types of the wave will be an attenuator type. An attenuator is a floating device in which operates a parallel to the wave direction and efficiently ride the waves. These device captures energy from the relative motion of the two arms of as the wave pressures them. Next, we'll see about the point observer. A point observer floating structure absorbs energy from all the direction through its movement at the near the water surface. It converts the motion of the bullet top related to the base into the electrical power. The power takeoff system may take a number of forms, depends upon the configurations. Here we'll see we'll be having the power stations in the sea, and then which is we'll be having the float and the span and cables which is carries the power buoys. And next, oscillating wave surge converter. Oscillating wave surge converters extract energy from the wave surge and the movement of the water particles within them. The arm oscillates pendulum mounted on the pivoted joint in the response to the movement of the water in the waves. Oscillating water column. That's what we have seen in that video. Okay, an oscillating water column is a partially submerged hollow structure. It is open to the sea below the water line, enclosing a column of air on the top of a column of water. Waves cause a water column to rise and fall, which in turn compresses and decompresses the air column. The trapped air is allowed to flow the air and
Yeah, sorry for the inconvenience. I think madam got disconnected. Madam might have some troubles in the slides. So probably let me go on with what she is explaining and I'll conclude it. Once she is able to join, then probably she can join. Sorry for the inconvenience. She has tried her best, but means network is not really supporting. So let me take her slides and let me share the slide and take it up very quickly. Yes, I think this is what the slides which she has. And I believe everyone is able to see my screen now, right?
Fine, sir, fine.
Yes, yes, my volume is also clear. Perfect. So this is what she is covering. So she has started with the tidal, then she has moved to wave, and then she is thought of finally coming to this OTEC, that is ocean thermal. So I think these are all the things which she has covered. Tidal energy she has covered in detail. I believe that's up to that she is clear. And I believe these are all the information which she has shared. That's fine. Here is where she has.
Hello. The one.
Let me go on. So that's about the tidal. Then she has moved on to wave. So the wave energy she has explained a little bit. So means no need to confuse like 60 hertz or something. You can convert it to whatever may be the frequency of the system which you have in your country. I'm not going to play the video again. this video which you can watch in YouTube. I don't want to waste our time. We have another eminent speaker who is waiting for. So, but wave energy, you can understand how it generates the energy from that video. Right. This is all what she's talking about, how this gets generating the electricity from wave. So finally, let me go to this ocean thermal. Obviously, I mean, this is another simple technique where you have turbine generators, evaporators, condensers, and water pumps. So means by understanding the difference between the temperatures that is being converted into electricity. So this is another video. I don't want to play that video again because that might be occupying some means what say bandwidth or probably the volume is not clear. If I means remove my headset, there could be some issues, right? So means what to say, the advantages and disadvantages which she is finally concluding with, it doesn't produce any greenhouse gases. Means whatever maybe all the three techniques which you can understand, that is extracting the energy from the sea. It doesn't require any fuels. That's an advantage, not necessarily for a tidal from all the three which you can understand. But when it comes to the disadvantages, I am not looking at this disadvantages. I am looking at it as challenges. Capital investment is high. That's what I believe. I am repeating this at least third time or a fourth time. Capital investment for a solar is extremely high about 20 years back, but that's not the scenario today. So means what say the research has to increase and probably how to minimize the cost without damaging the environment, right? I mean, what are the impacts of this installations on the sea animals like fish or anything? Means what to say that we need to really check. That's another important aspect rather than just looking at a cost. So cost is means high at present. That researchers has to work out. That's what I told. It is not necessarily a disadvantage. It has to be a challenges. And efficiency of this conversion is obviously low as on today. That's what probably when we have started with the solar panel PV has about 3% efficiency. Now in a research lab, we have about 54% efficiency, which we have reached. So I mean, efficiency as on today it is low, but that has to increase. So it needs a very large size, of course. Yes, that also size is another thing which we need to work it out. And the cost, expensive, it's all probably today challenges. I will not call it a disadvantages. This is a challenges which researchers has to focus to convert this into a means what to say affordable. At the same time, means it should not have any harmful impact to the environment which is of sea. With that, I'm concluding it. I'm sorry for showing other screens. Yes, I will let me stop the screen. And if there is any questions, Balraman, you can. Balraman, if there are any questions, we can take it up.
Proceed, sir. Proceed.
Okay. Madam has joined, I think. Okay, anyway, fine. I'm going to directly with the Jones to give an overall conclusion of this view. Jones, please.
Thank you, sir. And thank you, ma'am, and Silva sir, for this knowledgeable session on other renewable energy sources, sir. We get an overview about the tidal power plant, wave energy, and geothermal energy, and we have discussed several that is advantages and challenges on those things, sir. On the whole, I think so. We get a basic knowledge about how the tidal energy is generated and how the wave energy, that is electrical energy, is generated from the wave, right? So from this, I thank Madam once again for this interesting and knowledgeable session on this other renewable energy sources. Thank you, Madam. Thank you, sir.
Thanks a lot, Jones. Before I am inviting Lavanya Madam for the next, introducing the next speaker, I will go again with an announcement. We are winding up this report submission. The cutoff time is extended to coming Sunday, that is 14th June, 8 p.m. I request all of you to send your reports for all the 5 days to the email ID IGEN-FDP@gmail.com. IGEN-FDP@gmail.com is the email ID which you need to send your reports. If you have already submitted the reports for 1 or 2 days, send it the report for all other remaining days as well. You need not really send it, means what to say, they're already submitted reports, but we expect, means you have to submit all unit reports. If you have submitted few units already, please ensure that you are submitting for all other units as well. As we have already told, and Senthil Kumar has also promised from IGEN, we have increased the number of prizes from 1 to 3 prizes based on overwhelming response, and many people has asked some time for that they can prepare a good report. That's the reason why this date is also extended to Sunday. So with that announcement, I am going to Lavanya Madam to introduce the next eminent speaker.
Yes, sir. Sure, sir. As the quote says, tell me, I forget. Teach me, I may remember. Involve me, I learn. And the FDP, organized by IGEN and Panimalar Institute of Technology, makes our participants to involve and enjoy in learning. Next, we have our eminent speaker, Engineer Sivaguru Paramasivam sir. I am very pleasured to help to introduce him. He completed his BE EEE at Anna University, Chennai in the year 2006. He is a technical expertise in battery energy storage solutions, lithium-ion battery systems, characteristics, BMS algorithm protections, and battery system integrations. He is an expertise in microgrid application and ICE diesel generator integration controls with renewable energy systems. He is also an expertise in industrial automation and control, commercial and product expertise. He worked as a manager in energy storage solutions and hybrid solutions in Delta Electronics India Private Limited from 2016 to 20. He also worked in Parks and Hannifin India Private Limited from 2006 to 2016 as design and system engineer with project management and technical support. Currently, he committed himself as technical and commercial response for hybrid power projects in Masdar, Abu Dhabi. He is passionate and committed professional in engineering, technology, and business function. Now he is with us to give his ideas on industrial perspective of renewable energy sources, that is the other renewable energy sources. I welcome you, sir, for your valuable session. Please, sir.
Thank you so much, ma'am, for the introduction. Good morning, all, and I thank IGEN and Panimalar organizing committee for this wonderful event. So, with that welcome note, I would straight away go into the session. Yes, as introduced, I would be taking on the energy storage solutions today, and also I will touch upon the hybrid powers. Selva, could you see my screen now?
Yeah, perfectly. Yes, you can go to slide mode and you can go ahead. Yes.
Thank you, Selva. Well, so I have joined the previous two sessions. It was really wonderful, and also the previous sessions also talked about the other renewable sources. So that's the reason I straight away want to jump into energy storage and hybrid solutions. Well, I want to give some global facts and trends before I go into the subject. Let's understand why the world is moving towards renewables. So what is happening in the whole world, including the leading countries or the developed countries, is that they all want to go towards a net carbon zero, which means they have something called net carbon zero goal. You might have heard about a lot of policies coming from America, France, and European countries that the climate change need to be controlled. Like every year or every 2 years, we are seeing that a lot of environmental changes are happening. Either the temperature is going from 36 to 38, or the cold countries are getting colder. The places are getting more rains, more floods, and the Arctics are melting. So all what gives to us is that the world is changing, which is not good. And we as responsible engineers need to control that. And one of the ways is to control the amount of carbon that we are throwing into the environment. I think that's one of the main way that we can control. So with that, you can see I have made some 6 main points here. The first is like the governments around the world, including US, UK, Canada, and Japan, have announced that by 2050, that is 30 years from now, they want to go to net carbon goal, which means whatever the carbon, it does not mean that we are not going to emit carbon into the environment. So there is no development going to happen that way. But whatever the carbon we are going to emit, we are going to compensate it by some other way, either by absorbing it or either by preventing it by moving more into the renewable powers, things like that. So that's one of the main goals. And also you can see there are a lot of policies that technically are encouraging the electricity market to move into the renewable power and also the energy storage technologies, which we will cover in the next slides. And another important point I want to highlight is like 20 years from now, we will be having the solar and wind technologies, that is primarily the renewable power, going to 5 terawatts. That's a huge capacity. And also the hybrid powers, today we are in a 9 gigawatt size, and in another 20 years, we will be going multi-fold and touching a 1 terawatts. Most importantly, but to support all these goals, the technology, the R&D is also taking into large effects, and also the prices of the energy storage systems are broadly falling down. And between the time I started my career and now, I see that mostly like close to 80% of the prices have fallen down. You can see the two graphs around here. This graph shows that how, sorry. Okay. So this graph shows how the coal power is retiring and how the fossil fuel powers are retiring over the ages. If you see from 1980s to now and then going forward, you can see how the coal and traditional fossil fuel powers are retiring, and the renewable powers like solar and wind and other hybrid systems are going to increase. That's really a positive news ahead. And this curve below, graph below, also shows that from 2018 to 2040, how the renewable energies are adapted in various countries. So I have given this country-wise. You can see that China is leading with more renewable power, which means that out of the power that they are producing and consuming in the country, this is the amount of renewable power that they are consuming. So China is most, and US comes next, and positively India is third. So that's really a positive news for all of us. And we have, being a large country and having more consumers, we also have the potential to even overtake US and China. And you can see Japan is already having 9% of its electricity coming from renewables. California already have reached 50%. India, we have reached 35%. It's a excellent news, and we have a lot more way to go. Germany more than 50%, and other European countries and Australia, you can see they have already crossed more than 20%. So with this global trend, I would like to go into the energy storage to give you an introduction, like what is energy storage system. So traditionally, how we have been reading the electricity or handling the electricity is that the electricity is generated, it's transmitted, it's distributed, it's consumed. That's it, right? There is nothing in between. But with this kind of ecosystem, generation, transmission, distribution, and consumption, there were a lot of problems. There were a lot of challenges. And to overcome those challenges, we found that energy storage solutions can be introduced each of these nodes in the ecosystem, and it can do a lot of benefit at each of the nodes. It can even be installed in the transmission, it can install in the generating stations, it can even install be in the consumer end, and it can bring a lot of application benefits to everybody in the ecosystem. Now, we will see what are the benefits in the further slides, but I want all of us to understand what are the types of energy storages available today in the market. Mechanical energy storage, some examples are pumped hydro storage. You might be knowing that pumped hydro storage is having the water flowing from different levels up and down, and hence storing the energy. Compressed air, flywheel is similar to having a spinning wheel or a spinning reserve mechanism. Electrochemical is the most widely used technology according to the scale which we have seen today. And primarily we have two type of batteries in it. One is the secondary batteries. So secondary batteries are again the batteries which are rechargeable. So there are again two examples: primary batteries and secondary batteries. The one that we use in our home for the air conditioning or TV remote are all primary batteries which cannot be recharged. You have to use and throw it out. But the batteries which can be recharged again, you can use it, you can drain the batteries, you can again charge it, you can again use it. So there are certain number of cycles, there are certain number of times you can charge and you can discharge and you can constantly reuse that. All those batteries are coming under secondary batteries. And in this particular energy storage solutions, secondary batteries are only getting used because it has to be reused again and again. And there are two types. There are in fact various types: lead acid batteries, lithium ion batteries, sodium sulfur batteries, and also like flow batteries with a different constructional theory, with the two tanks with electrolytes in between, pump taking the electrolytes here and there between the electrodes to produce the power. Then there are electrical energy storage as well, which we know, we as electrical engineers, we all know capacitors and supercapacitors are all storing the electricity for a very short time. And this are, I mean, the supercapacitor applications are broadly used in marine, where we need a very huge power to be discharged within a very short time. And also there are chemical. I hope you have also heard about the fuel cells. Fuel cells are coming in chemical technology, where we have it's a chemical reaction of hydrogen and oxygen, and then that's flowing into the electrolytes, and then that's making the flow of electrons to make the power. Also, this particular technology of fuel cell have seen applications including industrial and also in vehicles. So there are also fuel cell cars. Some of the companies are making fuel cell cars as well. Thermochemical is also another technology, and thermal. So these are all, it's a very vast subject, but I would be more focusing on electrochemical technologies. I will tell the reason why I want to focus on electrochemical technologies. So let's understand where the energy storage technologies are used. So let us see this picture given at the bottom. In our day-to-day life, we don't pass any of our day without touching this technology. So let's take the simple example, the mobile phone. So we use mobile phones, and most of us use smartphones, and all the smartphones are using lithium-ion batteries in it, which means it has energy storage as the base component. And we use laptops, we use tablets, all having the energy storage technology in it. And the future, you can see we are also moving towards electric bikes, electric cars, electric vehicles. Even we are all moving towards a world where we will be having electric planes. And already there are companies who have proved that a plane or an aircraft can just operate, or even helicopters can just operate with energy storage technology, renewable and energy storage together, without any fuel used in it. And also, these are all the things that we know well, but they will focus more towards the grid scale or the utility scale applications of energy storage, which is what I wanted to focus in this session. And let's take a look at this particular picture that shows the kind of graph. You can see the x-axis of that is having the power rating. Let's understand this. The power rating, and y-axis is the discharge time. So before reading this graph, let me introduce you two terminologies in the electricity that we know very well. The one is the power and another is the energy. So to give an example between the power and energy, power is nothing but the amount of current, the amount of power that is used that as a load. But energy is with respect to time. So what is the power that we are taking with respect to this time? To give a simple analogy, you can assume a water tank and a tap. Like we all have an overhead tank at our home, and you can imagine the tank is storing a water, but when we open the tap, the water is flowing into the tap, which means that the tank will be having the capacity to be defined in terms of liters, but when we open the tap, the terminology changes as flow rate, which means liters per minute or liters per hour. It depends upon how big is the pipe, how big is the tap, how more the water flows. So that is the very similar example you can apply here to understand the difference between power and energy. And with this introduction, let me introduce how this is applied in the battery. So the battery is always described in a capacity that is called energy. It's not said in terms of power. So we will be calling, to give an example, you know that what's the battery used in your cell phone? It may be like 10,000 Ah. So which means 10,000 amperage can be stored in that mobile phone, and you can take out 10,000 ampere for 1 hour. That is how it is need to be understood. Like if you are going to use your mobile phone with multi applications, and if you are going to draw more current, instead of 10,000, you are going to draw 20,000. You are going to drain your phone in half an hour instead of 1 hour. On the other way, if you are going to use your phone idle without consuming anything, and if you are going to draw only 1,000 amperes continuously, then your phone is going to last for 10 hours. So let's understand this difference between the power, taking out the power and applying it with respect to time, and that is how it's translated to energy. Now, Apply the same technique here. This is the power, and this is the time you want to take the power from the battery. Now, if someone want a 1 kilowatt of power that need to be only taken out for few seconds, then this technology is best. That is how this need to be understood. So flywheel and supercapacitors are the technologies that can work only for few seconds to few minutes and not more than that. It can only store and discharge the power for very few seconds to very few minutes and not for hours. And that is why these technologies of flywheel, I'm not sure if you can see my pointer, but yeah, this particular technology, that is flywheel and supercapacitors, will be used only to discharge the power for few seconds. And based on scaling up of this technology, you can start from 1 kilowatts to 1 megawatts. You can put multiple of these systems in parallel, and you can take more advantage of using the power. And to understand it better, if you want something to be handling the discharge or the storing the power for more time in terms of hours, you can see lithium ion is one technology that can store power starting from wattage, very few wattage, to multiple of the megawatts. So that's the reason this technology I wanted to focus, and it has a lot of application areas in between, to starting from our mobile phones to our laptops to the large utility grid scale applications. We have lithium ion, and it can store powers from few minutes, like in our home we may be having the inverters. Yeah, those inverters are having lead acid batteries. Traditionally it will be working for 30 minutes to 1 hour, something like that. But industrial UPS, there are some lithium ion batteries, so which will work for 15 minutes to 30 minutes. And it can also be used for high power. It can work for a 10 kilowatt, it can work for 50 kilowatts, it can work for 1 megawatt. That is what this particular picture teaches us. And in our day-to-day life, I mean, if you can see the circle here, energy storage revolves around a lot of applications. We all use the mobile phones, and the mobile phones are transmitted through the mobile centers and the data centers, which are all operating with critical DC and AC components, needs 100% power backup. So even if there is a grid failure, this system, the telecom network, need to work. And, energy storage is broadly used there. UPS backup, which I have already indicated. Renewables are going to be the very big market. You can combine renewables and utility together, like we will cover the applications. And the electric vehicles, of course, yes, there are a lot of electric vehicles coming. You might have seen Hyundai Kona being launched, and now MG Motors. So there are a lot of companies already. This Renault. So there are a lot of companies, even in India, they have already launched their electric vehicles. So commercial and industrial, it's like kind of replacing the diesel generators. Okay, so now we understood what is energy storage, and how to nomenclate between various things. But to select any technology, and I have also told you that there are a lot of technologies, and there are a lot of solutions. But one will always get confused, like which technology to use for which application. If you have an application, how to choose. So let's understand this spider chart given here on the right hand side. So there are some key parameters that needs to be considered to take any decision in terms of technology. So energy density, power density. So to come from the bottom, temperature. So where we want to install this energy storage system, we want to install it in a place where we have 35 degrees or 50 degrees in a hot desert, or an ice land where we have like 0 degrees or even minus degrees. So that particular parameter largely impacts. So if we have to have a good temperature performance of the battery, then as you can see from the graph, lithium-ion is better. But if you want to choose cost as your main parameter, then lead acid is better, because this particular green graph is touching near to the cost parameter. And if you want the battery to have a large life, the high cycle life, usually we define cycle life with the number of cycles that the battery takes with respect to one full charge and one full discharge given in a day. So you can see some of the technology. So this is just to give you an idea about how the different technologies of lead acid, lithium ion, valve regulated batteries, sodium sulfur batteries are selected in any large scale or medium scale application or even small scale application with respect to the key deciding parameters. So again, this shows the very similar example of various technologies and what technology lies where with respect to the round trip. I mean, the efficiencies with respect to the cycles. This is self-explanatory. So I skip this. Well, so now we understood what is energy storage, what are the different technologies, what are the parameters to pick up to select an energy storage technology. Now, let's understand in the world with the applications that we have today, what is the share that each of these technologies are having? Like you can see broadly this blue taking lithium ion taking the most share, and next is the lead based batteries, and there are also, you can see in the recent years there are a lot of R&D activities, I should say, a lot of developmental activities are going on, which is striving to provide us a low cost and a high efficient battery. So this particular slide, I also wanted to touch that for all the academic people, like who are all into the in studies now and coming out from the colleges, they have a huge scope to get into the research and development of these battery technologies. This is, the technology is not done. This is constantly evolving, constantly growing. There are, as you see from the previous graph, every technology have its own advantage and disadvantage. Some parameters, some technology is leading, some parameters, some technology is bad. So which means there is going to be at least another 40-50 years. The technology is still going to be evolved, and then a lot of R&D activities are going to happen. So people coming from chemical background, electrical, electronics, control systems, communication systems, power systems. So everybody are going to gain from this particular technology ruling the world for the next many years, I should say, not few years. Well, so what is the manufacturing capability that we have globally? So you can see 62% China is leading this particular technology manufacturing, and followed by US and then Korea and somewhere some little parts of Europe. So there can be a question now why India has not adapted, though we have missions like Make in India and a lot of things. So why India has not adapted? Well, lithium is radioactive, and we can't just import lithium as a raw material to India because of various securities and the national policies that we have. So there needs to be a policy change in the government, and we have to broadly allow the manufacturing. Also, this needs scale. So it is not a factory that we can set up in 1 acre of land and then we can start producing it. It needs volume. There is some terminology in business, we call that as economies of scale. So when you have a factory, you have to have this much of capacity manufactured, only then you have the profit. So that is the reason India has still not adapted. But yes, with all the geo political things happening around the world, we feel that soon India will start doing this and will give all of us an opportunity to work in this domain while being in our country. This is a very complicated manufacturing process. This needs a lot of micro steps and an automated plant, a dry room, a vacuum control, dust control. So what happens is that the raw materials are collected and it's made as powder. Then we call that as slurry mix, where it is mixed with a lot of chemical components, and then it passes through the coating session. So what is happening in this battery? So let's come to the constructional features of the batteries. What happens in the battery is that there will be an anode and a cathode, that is copper and aluminum separated by electrode, and then it is bound inside a metal plate, and that's it. So between the anode and cathode and the electrolyte, the electrochemical reactions, the ions flow from one end to the other during charge and discharge on either of the directions, and that's how when you connect the connecting wires to these two nodes, we take electricity out of it. That's the DC power we take out of it. Now there is a coating and slitting, pressing, cell baking. So all these are done in order to ensure that all the cells manufactured, all the battery cells manufactured in particular lot is having same performance and characteristics. I'll tell you why this is important. Punching, and then it comes to cell formation. So this is typically the plant looks like. This is not exactly it looks like, but it is usually done in a multi-story vertical building, not done in a horizontal building, because it needs a lot of machineries to go through, and then so it can go up and down, so it covers a low footprint. That's why it's usually done in a vertical fashion. Well, I told you about the electrodes, anode, cathode into put into a battery cell. So this battery cell typically comes with a metal enclosure. There are again different types, prismatic, pouch type. So each technology has their own way of constructing it. Once the cell is constructed, this particular cell, it looks like a book with just two electrodes pouching out. So it looks like a book, and then multiple of these cells are packed together, and that is what we call as battery module. One battery module will have multiple of the cells, and then if you need more capacity, you can relate this slide to the previous slide which I have shown. Lithium-ion starts from 1 kilowatt to multiple of megawatt. If you need just 1 kilowatt, okay, you use just few of the battery modules. If you need 100 kilowatts, you put multi of the battery modules into a pack, you mix it up everything, you combine it all together, and then you make a pack that can give you maybe 100 kilowatt hours. If you want 1 megawatt hour or more, you put all the packs into a battery system that we call as a containerized solution. It can be a 20 feet or a 40 feet container. You put into this with additional protective features like firefighting and cooling systems, and that's what we call as a complete energy storage system in large scale. So I indicated that it also has communication systems and electronic systems. So this is not just chemistry. Lithium-ion battery systems are not just chemistry. It is electrochemistry, and it is in fact electronics bound. So there is something called battery management system. Since we have multiple of the active components integrated, connected in series and parallel, so there need to be a control logic or an intelligence sitting on top of it to control each of these passive components. So that is what is called as battery management system. In short, you can call that as BMS. That is the vital part of the component which is responsible for the safety, which is responsible for the performance, which is responsible for the life and everything that the battery needs to do. Okay, I think now we can go broadly to the grid scale and the large scale applications. So we know this power generation, then goes to a substation, then the power is transmitted, again it goes to a substation, it's distributed, and then it comes to us, who are the consumers. So let's understand this. So there are a lot of challenges. There are, okay, I think I have some slides to explain that, but as you can see this particular symbol, a box with plus and minus, that's the battery. You can see the battery can be utilized everywhere and anywhere, and it has an application to do in each part of the grid. And going further, we will be also having some technologies called VPP, that is virtual power plants, where we will have everything integrated together. We will be having the generating stations, we will be having the consumption, we will be even having a different source of generation all combined together into a centralized network. And then we will be effectively handling the power. We will have a need to effectively handle the power. And that's where the virtual power plants will come into play. And there will be one central load dispatch center or a grid control center who will be commanding, who will be seeing the gaps between the generation and the consumption, and he will be tuning the energy storage system so that it is not loading any of the factors, and it is helping all of the sources and all of the loads to work in a streamlined way. And battery can also be used largely into the renewable systems, not just into the traditional grid, but also into the renewables with solar and grid. We'll see some examples in the next slides. This may be interesting. So let's take some of the application. As I mentioned, there are more than 15 of applications, if not more, definitely. But let's take what is peak shaving. Let's understand this. So how are we know how the electricity bill is charged on us. So there are two parameters, right? One is for the charge that, I mean, for the power that we consume, and another is for the demand that we have kept. So that is why in residential, so for example, in residential, we are capped with a capacity of 3 kilowatt or something. We can't exceed 3 kilowatt, more than 3 kilowatt. I'm just giving an example, different from place to place. So that 3 kilowatt is one slab, and for small scale industry, for example, if it is 20 kilowatt. Now, if you are 3 kilowatt, then your unit charge is like 3 per unit, 3 rupees per unit. And if you are 20, then you are like 4 rupees per unit industrial. Now, you need to decide whether you want to be in this cap or in this cap. Unnecessarily, if you want only 3 kilowatt and if you take a connection of 20 kilowatt, then you are paying something huge, not just for the electricity that you are consuming per day. So very similarly, there are two lines marked here. One is the consumption that you do, and another is the demand, that is the peak demand. So the orange curve that you see here is the consumption pattern you imagine in your home or industry, whatever it is. You can see at some point of time, maybe in the evening, when we go back from work to home and we switch on everything, the lights, air conditioning, fan, everything. So there is a case that the load is increasing. At that, because the load is increasing for a very short time with a high peak power, we don't have to increase our demand, which will increase the cost of electricity as well. We can install an energy storage, and here you can see in this zone, we are not touching this line. So that gives us the flexibility to charge the batteries, right? So we charge the batteries during the day. And when we need more power, when we need, the demand is high, instead of taking it from the grid and paying more or paying a penalty, you give it back, or you take it back from the battery. So that's one of the applications that we call as peak shaving. These are some real life examples applied in small scale and medium scales. And capacity firming. So let's understand, we are living in a town, and that particular township is going to increase vertically. We know that Chennai and many parts of the India are all vertically increasing. When I say vertically, apartments. So there are not individual homes. So in apartments, instead of one home, in place of 6 homes, we have 60 homes. So the load demand is also going to increase. Now, what will the electricity company do? So if they have a transformer of 100 kVA, they will be having, in the next summer, they will be having demand of 150 kVA coming from that particular zone. So they cannot increase the whole infrastructure of the grid, starting from the transmission lines to the transformers to the cabling, the overhead lines, everything. It's very, it's practically expensive, though it's possible, it's practically expensive. So energy storage plays a role there. So what energy storage can do, we fix the energy storage in that particular location. Whenever there is a peak demand coming from the loads, the batteries are already charged when the loads are low, and when the demand is high, you take it from the battery and use it back. So that's one application. So you see this particular graph at the bottom, that's the grid frequency regulation. And okay, this is the, before I touch this example, I hope you remember our Prime Minister told last time, 9 minutes, 9 o'clock, 9 minutes, switch off everything, right? So what that impacts to the power grid is the generation is same. The generation is same. We are not going to control the generating stations, but the consumption is going to drop drastically. Everyone are going to switch off. The nation is going to turn off everything. So the consumption is going to drop. What happens in between? The generation is same, the consumption is dropping. So what happens? The frequency, the grid boost up. It picks up and it exceeds beyond 50. And there is a limit, there is a bandwidth between which the frequency cannot go up or down. So if the frequency, or on the other side, if the consumption is more and the generation is less, then the frequency will drop. Now, that is happening in most of the European countries, particularly in the UK market and Australia market. We are working on real-life projects. So we install large energy storage systems like 20 megawatts, 30 megawatt kind of systems, and then we monitor the grid frequency. As you see from here, the grid frequency at this particular point is increasing 50 hertz. So what the battery does, the battery will absorb the energy. When I say the battery will absorb, it charges from the grid. It gets charged from the grid. And when the frequency drops, it pumps the power back to the grid. Hence, it helps the frequency to get stabilized. So this is a very, very important application. And broadly, we are using this in many of the countries. And this is one of the great revenue models as well. This is not just an application that we do, but with this application, we earn million and million of dollars from the grid companies by doing this kind of application, and this is going to remain. So there is no way that the frequency can be regulated in the generating station and the consuming end. So energy storage is going to have a vital role for these applications. Well, we will go to hybrid power systems now. I would like to start from explaining the word hybrid. So what is hybrid in our understanding? Hybrid is nothing but a mix of two or more technologies. So when we have an individual technology that is named by its own name, for example, a petrol engine or a diesel engine, which is represented as an ICE, internal combustion engine. In all our cars, we have ICE, internal combustion engines. And there are also cars that work on electric. So we call that as electric cars. Now, there are also something called hybrid cars. So what does that mean? Hybrid car means, you know that Toyota Camry is having this hybrid. Camry hybrid itself is a model name. So what it has is that it has part of the ICE, it has the petrol engine, and it has also a battery system also equipped with it or combined with it. So this particular car uses both the technology together, and it takes the best advantage out of it. So when there is a demand, like with respect to the acceleration, with respect to the torque, with respect to the pickup, it switches between these two technologies, and that gives a great flexibility to the user. And that's what hybrid as a system brings as multiple benefits, not just one or two. Like as you see from this image, hybrid hybrid power systems is a power system that has one or more type of renewable sources mixed with it, and it is going into the common grid. Like if you see from this picture, it has a solar power, it has a wind power, it has a thermal power station, it has a factory, it might also have a diesel generator as one of the sources of power, and it has various consumption points. And in between, the primary component, I cannot say primary component of the power system, but the important component of the power system is energy storage, because when you mix two technologies, there need to be someone who should understand both of them and who should control both of them, and that's where energy storage is actually benefiting the adoption and the sustainability of the hybrid power systems. Now, what are the benefits that the systems bring in? Like flexibility of flexibility of managing the grid. Yes, as I told you, if you have just one source and one consumption point, you don't have any flexibility. You have to, if the generation drops, you have to do load shedding, which means you have to switch off the loads. But if you have this hybrid, you have the flexibility. If solar is down, you take from the wind. If wind is down, you take from thermal. If thermal is down, you still have the flexibility to take from the diesel generator or from the energy storage. That's the flexibility. Self-sufficiency. You don't have to connect this network to anything else, because this particular network itself is self-sustained. And reliability. As I told, SimCity is having more than 2 or 3 generating sources. It's highly reliable. You can rely on power. You can get 24/7 power. And lowering the energy cost. Though the initial capacity or the capital investment of the plant may be higher in terms of the investment, but the overall benefit or the long-term benefit with respect to the energy cost would be better. And it is also referred to as smart grids. In future, as I told, we all go towards the virtual power plant. So it's all going to be smart. So what is smart? Like if in terms of power system, what is smart is like one component need to communicate to another component and understand what the system needs. So that is smart, like, which means it should have a communication mode in it. It should have a communication. It should have a sensor. It should have a controller. It should see what the other guy is doing, and then he should adapt himself in tuning the amount of power he is drawing or giving back to the grid. And that is what is the smart grid. Electrification, we know at least like 2030 we will be having most of the electric vehicles with all of us, and then that is also a load that is imposed on the grid. Electric vehicles is nothing but it is a stress on the grid, because it is going to be additional loads, and we as smart engineers, we should also think like how we can overcome that. It should not be a challenge, but this should help the electric vehicle incoming to the system faster. Well, so in hybrid, as I told you, it's having 1 or 2 different sources. So let's understand how an energy storage system will help an hybrid, like if it is going to get integrated with the solar farm. So you can see this particular solar curve, that is the dark blue that's given at the top. Now, typically the PV generation of a bad day will be like this. When I say bad day, which means it is having a poor weather condition, it may be too hot, it may be like cloud covered. So this is how the PV generation looks like. It's not giving a constant power with respect to time. So you consider the x-axis as from 6 a.m. to 6 p.m. and you consider the y-axis as if it is a 1 megawatt farm from 0 kilowatts to 1 megawatt. You can imagine that way. You can see the power within few seconds or within few minutes, it's changing up and down, and which is not good for the grid. The grid cannot, if it's 1 megawatt, it's fine, but if it's multiple of the megawatts, you can't just throw an irregular, non-regulated power to the grid, and it's going to spoil the power parameters of reactive power, voltage, frequency, everything of the grid. So what we do, and this is a broadly adapted application globally, even in India, we have these applications. You can see that. Let me tell you to see the second graph here, the second picture. The blue line that you see here is from the battery. So you can see here at this point where my arrow is showing, the solar power is increasing, and that time it will be doing a moving point average. So it will be seeing like for the last 15 minutes or 20 minutes how your graph is declining or approaching. Like this is called one adaptive algorithm we do with respect to the previous power. We see that whether the power is drastically increasing in the solar from the previous minute to this minute, then the battery will tune it. The battery will either absorb the battery, or it will either give back the battery. It will absorb the power or give back the power, so that the net resultant of the solar power, you can see the green curve, will be smooth, because the battery is working here in order to regularize the PV power, so that the net power given to the grid, you can see the green curve here, it is comparatively smooth with respect to what you see at the top. Like between this blue and this green, you can see this green is good curve, which means this kind of power flow with much regulated power is good to go into the grid. This is one hybrid application. It can be applied to both solar and wind with energy storage. And this state of charge, that SOC is nothing but state of charge of the battery. So with this particular application, how the state of charge of the battery is going to impact. So that's one thing that we are showing. Energy shifting is another application. This is nothing but when the solar is more compared to the load requirement, you straight away put it into the battery, and during the night time when there is no sun, you use the battery to give to the grid, so to your loads. Now there is another one application that is called diesel hybrid, that is using a diesel generator with a solar power, or in combination with solar and energy storage. So if you take a case, the red line is your load. Imagine that the red line is your load and you don't have grid at all. You imagine this place is not having any power grid. Now, and you have only diesel as a source. Now what you will do, you will have to overlap the yellow is the diesel here. You will have to overlap the yellow line with the red line, because you have only diesel generator as the source, and diesel generator have to run 24/7 to work for this particular load networks. But if you have an energy storage integrated to the diesel, what you do is that you switch off the diesel completely, diesel engine, diesel generator completely. The battery is charged, the blue line here. The battery is slowly discharging here with respect to time. You can see why this is discharging, because it is supporting this power curve. So the battery is discharging. At this point, the battery has reached to a threshold level beyond which it cannot discharge. So at this time, we switch on the diesel generators at its full power. While the diesel generator is working at its full power, only 30% of the diesel generator is used to charge, or it's used to satisfy the load network, but remaining 70% is used to charge the batteries. You can see the battery profile again going high. And then you switch off the batteries, switch off the diesel generator again. The batteries come into play and the battery is fully discharged, and it keeps on. It has multiple benefits. It keeps on following. It has multiple benefits. The diesel generators are having longer life. The diesel generators work in a much efficient way, because there need to be a minimal load for the DGs, for the diesel generators. This is one application. So with this, I think I will be interested to tell one real life example where we have executed one project. That's diesel energy storage come solar project. So one project was we have done in Africa. There was one, there are a lot of townships and communities where they have colleges, medical institute, engineering colleges, and a lot of things together. But unfortunately, they didn't have power, like the grid power networks were not there. And what they do, they run large diesel generators, like 1.5 MVA, 2 MVA diesel generators. And because they use diesel generator as the only source of power, they will only be able to operate it for 2 to 3 hours in a day. Which means the students and the whole community are living there with only 2 hours of power in a day. I'm not talking about 1960s, but I'm talking about 2019. It was really shocking. And it was so pity. I mean, you can imagine how a medical student or an engineering student will survive in that kind of environment. So with the help of a lot of agencies, including the government officials, so we went there, we studied the project, then we installed that. And after installing that solar and energy storage and diesel generator, which is collectively called as an hybrid power project, so the whole community was gained, and the community is now running without switching on the diesel generator for last 6 months. It's 100% working on green and pure power, and they are, I cannot tell they are happy, but they are more than happy. So that's one of the proud moments that at least I have seen in this particular hybrid energy projects in real life. And for sure, this particular technology is going to have its impact in many places of the world. And that's going to give all our next generation students a lot of opportunities to put their hands into this technology and do a lot of innovations. Well, so how an hybrid power system model works like? So this is just a broad model. This is nothing like a simulated model or something, but to give a broad picture in between the generating, consumption, transmission, this I have already touched upon. So this shows how the connection points are made. So you might be surprised that how energy storage can be connected to the traditional grid. In what ways? It's nothing, like it can just go in parallel. You can see the batteries here. You can see a power conversion system. Power conversion system is the batteries are DC power, so it has to convert to an AC power through a transformer. It couples to the power grid here. So it can, any hybrid system can just come and couple to the existing network in parallel. So if there is a problem with the new technology, we can very well switch it off, take it out, and still we can keep working with the traditional power, or if we can couple the hybrid system to it, and we can make a lot of advantage. So that's what this shows, and I think I'm almost at the near end of my slide, and hope it was helpful. So open for your comments, please. Thank you. Thank you for your patience.
Thanks a lot, Sivaguru. Now we can take up a question, I think, from the participants, those who are joining in YouTube. I could see there are quite a lot of good responses for you in YouTube. Now I am going with the Durai. Probably if you have any questions.
Yeah, sir, there are multiple questions.
Yeah.
Yeah, actually, sir, first of all, thanks for such a wonderful presentation, sir. Yeah. How the cell balancing impacts while designing the BMS?
Impact designing the BMS. Okay.
Yes.
Well, okay. Cell balancing is nothing but if you have in simpler terms, imagine that you have 2 cells and you are connecting these 2 cells and you are taking the power out of these 2 cells. Usually, if you want to have a good life of the battery, both the cells should start discharging at the same rate, and again it should start charging at its same rate. If the cell 1 is charging in a slower rate and cell 2 is discharging in a faster rate, then there is an imbalance. That is what we call as an imbalance. So this imbalance can happen in terms of voltage. This imbalance can happen in terms of temperature variation between these 2 cells, or this imbalance can also happen between the current that is given out of these batteries. And how it impacts is that when you have 2 different cells deteriorating in different rates, the faster deteriorating cell will also pull the good cell faster. It will also make the other cell bad. It is like when you have a bad friend, the good friend also becomes bad. The very similar way, this cell pulls the good cell also, and then it impacts. So now what a BMS does there is that the BMS, here comes the intelligence. So it monitors the temperature of each cells. It monitors the voltage. It monitors the current that is drawn out. Now, if there should be a temperature difference between these cells, the battery management system cannot do anything because temperature is an external factor. But there is an adaptive algorithm applied, like it will check the voltage and it will allow a delta 2, like 2% of variation in the industry practice. 2% of variation between these two cells are allowed. And if the difference is going to go beyond 2%, then it will start taking power from the bad cell and it will make the good cell to discharge, so that this also comes to that level and then it will start working together. So this is immediate corrective action. But if the situation is going to keep on repeat, then the BMS will give an indication to the user saying that there is something wrong with the cell and it needs to be replaced. I'm telling this in a cell level, but you can apply this in a module level, rack level, and even in the broader system. So this is just a layman kind of example.
Yes, sir. Thank you, sir. Another one question: how can we handle increase in temperature while we are moving to lithium-ion battery for large storage applications?
Increase in temperature, there are again, I don't understand. Increase in temperature can refer to two parameters. One, increase in the ambient temperature of the place where we install the system, or increase in temperature of the cell itself. So I'm not sure about the question, but I will try to answer imagining, both the cases. If the question is about the ambient temperature, how we are going to adapt lithium-ion technology with respect to installing it in a place like 40 degrees or 45 degrees, even 50 degrees, then there need to be an external system that need to be constructed around the batteries, like an battery containerized system with proper HVAC. When I say HVAC, it's heating, ventilation, and air conditioning. So though the outside temperature is 50, the container will make the internal temperature to remain within 25 to say 30 degrees. That is one of the ways that we can do this. But if the question is about the other way, that how the internal cell temperature is going to increase, so how we are going to handle it. Now there is already the first layer of protection coming up from the cooling system, but still, if the cell is going to keep on increase, there is nothing the system can do other than disconnecting the system safely, because we need to have the protection. That's more important than operation. Protection is more important than operation. Then we will find out there might be a choke in the forced cooling fan, or there might be some temperature sensor failure or whatever it is. Then the engineers rectify it before we put the system into action.
Yes, sir. Thank you, sir. Sir, another one question, sir. Actually, I think it's the last question. Sir, what is the difference between lithium ion and a lithium polymer?
Okay, lithium ion and lithium polymer, it comes mostly with respect to its construction. In my understanding, every electrochemical batteries are used with respect to movement of ions. But if we say lithium polymer, in lithium, polymer, there are again different chemistries, LFP chemistries, lithium ferrophosphate, or lithium NMC, manganese cobalt. So in certain construction of the cell, what happens is the two small cells or the electrolytes are bound with respect or in a kind of pouch arrangement, that is a polymer material. So they are packed inside a polymer material that is called as polymer pouch cells. But in the other technology, what we do is that we put inside a metal can with a proper aluminum, small aluminum container. So the construction is making a difference here, I should say.
Yeah,
yes.
Thanks a lot, Sivaguru. There are quite a lot of other questions. I don't want to miss out the questions, because previously the sessions we have cut out into 2 or 3 questions. So we will go ahead with many more questions. So probably shall I take your 10 more minutes, 10, 15 minutes more?
Yes, no problem.
Yeah, because even I have to say sorry for all our previous programs. I couldn't give you enough time. I believe this time I will ensure that I'm utilizing to your full potential. There is a very good question from Sridhar Sharma. Out of batteries and fuel cell, which technology is better for power generation? So I am intentionally putting this question because people are always confused with the power generation from fuel cell. They also think that the battery will generate power. The question is from Sridhar Sharma: out of batteries and fuel cells, which technology is better for power generation?
If the question is power generation, then simple answer, fuel cell, because battery is not a power generating source at all. Battery is just a power storing source. But fuel cell can produce power. Fuel cell with an input of hydrogen to it, it can give the power. Also, it can give water as a byproduct. So that's an external. That's a good source of power. batteries are different. It cannot produce the power. It can only store. A battery can never produce a power, but the power produced by a fuel cell or produced by a solar or produced by a wind or a thermal or anything, it can store it and it can give it back to you in another point of time. That's it. So that's a big difference. Yeah.
Yes, yes. No, means I have put up this question for not only for his sake, for everybody's sake. Everybody thinks that the battery is a source. No, battery is not a source. It can store the energy for the duration, right? But whereas a fuel cell is the really a source. I'm going for another question from Sridhar itself. Is fuel technology introduced in our country?
Yes, fuel cells are introduced in our country. I have seen that one project in Bangalore, in Electronic City. If I'm not wrong, I'm not sure. Yeah, in Wipro. Yes, in Wipro.
Intel.
Intel. Yeah. Sorry, Intel. There is a project for fuel cell, but there are some problems because it needs a lot of infrastructure. It needs hydrogen input to it. It needs some constructional space. A lot of things. So because of that particular challenge, people are not adapting it in a larger way. But yes, we have a lot of references even in India.
Yeah, to add it, the Intel R&D campus in Bangalore has that fuel cell based installed capacity of about 5 megawatt, 2.5 megawatt from phase 1 and 2.5 megawatt in phase 2. L&T has executed that job.
Yes.
From our end, actually, power projects, we have done a power storm study. So we are know about that projects bit more. So that's an additional information. But to cost perspective, I also talk about this fuel cell technology. I believe that we have missed it as a part of the syllabus. That is not really commercially viable because academic side, madam has touched many other sources, but means you have touched battery energy storage, fuel cell, we have missed it. So fuel cell, the cost is quite expensive. I mean, so approximately wind, you may be able to get 1 megawatt at 4 crores or something. But fuel cell with the Bloom technology, probably you might be aware, Sridhar from, So the cost is approximately about 40 crores per megawatt. That's the only thing where, I mean, still a long way to go from the making the commercial sense.
Capital investment is correct.
Yes, yes. So there is another interesting question from Prabhakar Reddy. We have solar lights with lead acid batteries. Can we replace them with the lithium-ion batteries? That means they are already using lights with the lead acid batteries. Now their question is, shall they replace that with a lithium-ion battery?
There are a lot of applications of lead acid being replaced with lithium-ion. Lot of applications. Even I myself have did many projects with respect to that. And for this question, it's a plain answer. Yes, because lithium-ion batteries. I'm not sure what lithium-ion, lead acid you are using. It may be a 2-volt cell or 12-volt cell, whatever it is. But even for that particular small capacity of 500 whatever or 1 kilowatt hour, you have lithium-ion cells. And even that comes as compact and that can be replaced. And another input I should give you here is that I'm sure that these you are using in an outdoor environment where it needs a good IP protection. This lithium-ion battery technology which I am talking is also coming up with IP65 case, so that it can be straight away kept in open environment without considering or worrying about rains or winds or even dust.
Yeah, yes, Sivaguru, thanks. And there are quite a lot of questions from the participants inside Zoom as well. So, means to give an overview, the session is in Zoom and it is getting live in YouTube. And there are many people are joining in YouTube. The people, those who are discussing actively are putting a right questions. We have decided to brought them directly in Zoom. So in the chat box, you can see there are quite a lot of questions. But anyway, for your benefit, I will read out the question so you can answer that question. First question is from Venkateswar Rao can you explain the aspect of compressed energy storage in electric vehicles? Recently, one of the car prototype is released. Can you explain this? Any idea on that?
Compressed energy storage was actually used for higher capacities, but it is yes one of the trials that we are doing for a smaller capacity for the electric vehicle. I should say that is only on a research site we are doing it, but it was proven. The compressed energy storage was proven if the capacity need to be like more than 10 megawatts or something more than that. Because you know the construction and the components required for that need to be in that scale. So yeah, I'm not very sure how this technology will be taken forward with respect to the electric vehicles, but it's under research.
Yeah. One more question from panels inside in Zoom, Paul Raj Palanisamy. What do you think about LTO? cycles will be 15,000 to 20,000. So
yeah, LTO, yes, that's the only, that's one of the big benefits of LTO. I mean, LTO and NMC are similar with respect to the characteristics. So it's a little deeper when I say characteristics, how the degradation happens and everything. But lithium titanate gives an advantage of 12,000 to 15,000 cycles. Yes, that is one good thing. And where the LTOs will gain advantage, let me tell you. So there are projects which will call for renewable integration of energy storage, and the project life they will be telling us 25 years, because the renewable projects are already satisfying 25 years, and they want the integrated energy storage also to work for 25 years. So for that project, if you have LTO, it may be good, because after 10th year or 11th year, you don't have to replace the battery. So usually what happens in the battery system is that after the 4,000 cycles or 5,000 cycles, the whole battery systems, at least the core cells and modules, are replaced. And in the 11th year, that is called augmentation, capacity augmentation of the battery. So we do a new level of augmentation into the batteries with other technologies. But in LTO, we don't have to do that, because 15,000 itself is corresponding to more than 20 years. So if you need a long life, high power, particularly for 1 hour backup kind of thing, LTO is really good.
yeah, thank you, Sivaguru. Again, one more question. What are the storage systems which are economically nowadays and are used in the utility? That's the again question from the panel inside in Zoom.
Utility, yeah, there is always a fight between flow batteries and lithium-ion batteries in some of the places, because flow batteries again prove that they have a very long time, I mean life, 25 years, you don't have to replace, there is no problem at all. And only problem is that the efficiency is low. If you are not bothered much about the efficiency, if you are okay to lose like, because efficiency somewhere stands like 68 to 72%, if you are okay to compensate on the losses, then flow batteries are good. Even we are also evaluating in some of our projects. But when we compare the LCOE calculations and all that, like levelized cost of operation, we find that lithium ion is better, because in lithium ion you can do multiple of the application. Like you can do a 15-minute application, you can do a 30-minute application, you can do a 4-hour application with just one system installed. But in flow battery, you don't have that particular flexibility. So which means, I mean, I know my answer is not straight, but this particular technology will always be evaluated with respect to the application and the use case. So we thoroughly analyze the application and use case, and then there may be a thin line of difference between these two technologies. So which gains better, we pick up that.
Yeah, to add upon, probably I believe yesterday's speaker Balraman has talked about this commercial viability of each and every project. That's where it has to come in first. Before you're going for a project, you have to assess commercial viability using some simulation softwares like Homer Pro or something. Then you have to find out what is the optimal capacity. Then you have to go for that project.
Exactly. Yes, sir.
Yeah. That's one more interesting question from YouTube. That is from Sachin Sinha. As you are saying, the battery can be used to meet the peak demand, and we can save on the maximum demand charges. But what about the battery maintenance and its life?
That's why I have been frequently telling that lead acid and lithium ion. So in lead acid, yes, the frequency and maintenance, I mean, the maintenance and frequency of replacement is more. You replace the batteries between 3 to 4 years, and you have to maintain it. You have to refill the distilled water, whatever it is, more. But I was focusing more on the lithium technology, where it is maintenance free. You don't have to. It can even be installed in a man-free zone, and there are many projects that are running in the deserts and in remote locations, even without people going there for years, 1 or 2 years. So the system still works without doing anything. So there are new technologies coming where you don't need any maintenance at all. Any maintenance. When you say any maintenance, you don't need any maintenance, because we are also backing up with a proper containerized system with IP54 protection and all that. So no point of dust going into it. Nothing is required. It's fit and forget. There are technologies coming up like this, and it's already adapted.
Yeah, thank you. I think there are quite a lot of other questions. It's also in YouTube. I couldn't follow it up both parallelly. Yes, Trey, can you just consolidate any quick questions in YouTube? I have seen 2 or 3, but it's keep scrolling. I couldn't track the questions. Durai?
Sir, yes, sir.
Yeah, you can take up few questions because I think I could see quite a lot of questions, but unfortunately it's scrolling, so I couldn't take it up.
Sir, actually, Naveen asked about some safety-related question. Is battery disposal also a major concern such that India is not into battery production?
No, battery disposal is definitely not a reason for we are not starting the manufacturing. I already told one of the reasons for manufacturing. It purely depends upon the scale that we have. So install one particular, I'll give an example, a real example. To install one plant, you will at least need half a gigawatt hour of production capacity in India, like at least 500 megawatt hour of production that you need to do so that the factory can sustain, because the factory has a huge capital investment, operational cost, labor cost, a lot of things it has. So if you have minimum 500 kilowatt hour of battery production from your plant, then it is good. And that 500 was like a story 8 months ago, but today it may have been like 800 kilowatt hour, even sorry, I'm telling kilowatt hour, megawatt hour. It might have reached even gigawatts today. So that's not a reason. It's purely driven on the capacity. But coming to the recycling, yeah, recycling, India as a country can easily do recycling, because today there are countries like Singapore who are leading in the electronic recycling. We know that Singapore is a very small country in terms of land space. If they can do this, India is such a vast country with a huge landscape, we will definitely able to do. And once we have these technologies coming in, we will surely establish the other part of the ecosystem. And before disposing, the batteries will go into one more cycle called second life batteries. We will not be just throwing out the batteries. After the completion of end of life of the batteries, there are some applications where you can put the batteries again. You can do some activity to it, and you can use the batteries again in different applications before it is being disposed. So there is a long way to go. And India as a country, as a technology, we are already ready for it.
Sir, another one question related to EV. How to assess the battery life of electric vehicle when you plan to buy?
Okay, simple. You have to see what is the kilowatt hour of the battery, kWh. Usually it comes with 40 kWh. I'm just giving an example. In electric cars, it may be like 40 kilowatt hour. That's one thing. Like if you are getting 42 kilowatt hour of battery, then it is better, because it is going to give more this thing. One is going to give you more longevity. So let's understand two things in electric vehicle. One is the longevity and another is life. So when I say longevity, you start your car now, start from Chennai, you drive to Pondicherry, and then you come back. Probably you are covering 300 kilometers, and this is called longevity. How far you can drive your vehicle with just one charge is one parameter to see when you are buying the electric vehicles. But how long the battery can live in your battery without replacing it, whether it's going to be 6 years or 7 years, that is another parameter. So you should be knowing which parameter you want to give importance based on your need. If you really want to cover more distance in a day without covering, without charging, then you may have to choose a battery which is having a higher capacity. Or if you want to have a higher life, then there are, again, you may have to go into the cycle life of the batteries and the charge rate, charge. Usually, I don't think OEMs will reveal all that, but technically, if you want to evaluate, these are some of the parameters.
Yes, sir. Sir, another question, sir. Actually, we are telling that fuel cells are better than batteries. Then why we have to go for a lithium-ion batteries instead of fuel cell?
Yes, so that's what we answered. There is a difference between a fuel cell and battery, because fuel cell is a power generating source, but a battery is a power storing device. So there is application-wise, there is the fuel cell and a battery is never a competitor. So it's always a complement to each other, I should say.
Yes, sir. Another one question, sir. Which one or two are the best suited for Indian conductors, both in terms of possibility and feasibility? Among all possible renewable energy systems, which one or two are the best suited for Indian context?
Definitely solar. And that's why we see a lot of solar gaining. And no need to say about wind, because wind was the father of solar in India. Even before the birth of solar, we had a lot of wind generation. So in the scale, you can see like solar and wind are really good. And only challenge with these two are like these are intermittent source of power. Like it cannot give a constant throughout a day. That is why the hybrid systems are coming in. So when you combine these two, I'll give an example. So you combine solar and wind. Solar gives the best power between 12 p.m. to 3 p.m. in a day, and wind usually gives the best power in the midnight, like 12 a.m. to 4 a.m. something like that. So throughout the day in a 24-hour cycle, you get good full utilization of power with both two. And in between, if you still want to bridge the gap, then you go for storage technology.
Thanks a lot, Sivaguru. I know you have a potential to answer all the questions till the end of the day, but okay, means we are running short of time. And I also probably to put across the participants, those who have joined in YouTube or even in Zoom. So if you take two eminent persons, those who have joined from industry, Yuvraj as well as Sivaguru, means I know the value for their time. Probably their company might be charging at least, I believe, $1,000 per hour. Let me repeat this. Their company might be charging their customers at least $1,000 per hour. That is hourly charge. I am not talking daily charges or monthly charges, because I am also into this consulting and microgrids. I know that value. So probably means what to say, you may not be able to expect, what to say, giving a complete picture of their expertise, what they have gained over 2 decades in an hour. But I strongly believe they have, what to say, distilled their expertise and they have said it in few minutes. Definitely, I believe that gives a spark for you, and it is your responsibility to carry out that spark, what you have been received from the experts, and you have to take it forward the momentum. And yes, probably means we are from power projects. If we are anything related to this microgrid or energy storage, we are happy to support the research scholars or the students, those who are willing to pursue further on this microgrid and energy storage, of course, renewables. Now we will go to Jones to give a takeaway. Jones, please.
Thank you, sir. Thank you very much for your wonderful session on battery energy storage and hybrid power system. From your session, we take away that rate of fossil fuels are retiring and renewable sources is increasing in generation all over the world. And also we take away that energy storage solutions can be applied at any level and various energy storage solution techniques. And we gain knowledge on ESS technology selections and various parameters to be considered while selecting the technology. And also we gained the knowledge on ESS manufacturing capacities and manufacturing capacities of various nations. And also we gain knowledge on lithium ion cell production process and battery system assembly and control, sir. And at last we gained knowledge and a clear idea about the basic concepts on hybrid power systems and advantages like flexibility, self-efficiency, reliability, and lowering of system cost. And also this hybrid power system helps us in smart grids and electrification of transportation. On the whole, your session gives enormous knowledge about the energy storage as well as the hybrid power system, sir. On behalf of Panimalar Institute of Technology and IGEN, I thank you very much for providing a knowledgeable session through this FDP, sir. Thank you, sir.
Thank you, Jones. I take this opportunity to thank IGEN, the organizing committees, and Panimalar Engineering College as a whole. Also, special thanks to my friend Selva to make this happen. Thank you so much.
It's my pleasure, Sivaguru. To be frank, actually, it's a Friday for him. It's a holiday. He's in Abu Dhabi. Friday and Saturday is a holiday for them. Means it's a bit early time. And despite of all, he's coming up and he's putting up the beautiful session. Definitely, your session has enlightened just not the people's, about 15 people have joined in Zoom, but also about 150 odd audience, those who have joined in YouTube. Thanks a lot, Sivaguru. It's my pleasure to be with you. Now I am going to Lavanya, madam. Madam, please.
Yes, sir. Sure, sir. There is a saying, the mind is not a vessel to be filled, but it is a fire to be kindled. And I'm sure that our faculty development program organized by IGN and Panimalar Institute of Technology kindles the minds of our dear participants. Next, we have an eminent person, Dr. L. Ramesh, sir. He is the Dean in Dr. MGR Educational and Research Institute. Probably he is the president of the IGN, Institution of Green Engineers, and he's the man behind the successful 5 days valuable faculty development program. There is a saying, research is to see what everybody else has seen and to think what nobody else has taught. And I welcome our IGN president to give the research views on the renewable energy sources other than solar wind. Thank you, sir.
Thank you, ma'am. Thank you, and we all coming to the end of the day. Thank you all the participants who are watching continuously for last 5 days, and thank you Selva, and thank you ma'am who introduced me, and it is great that lot of people participated. It is very good that we started the initiative like unit based, syllabus based, and it extended with a 4 different view. Okay, coming to the research point of view for the unit 5, what today I am going to not going to take more time, within 15 minutes, more than minimum 15 minutes we are planning to close the research session. I have a little more slides, but I will quickly go through all so that you can able to know what kind of review which happened in the wave energy, tidal energy. This tidal energy, wave energy, these combinations very beautifully, a person done a beautiful review, literature review, which I am going to discuss with you. Second part which I am going to discuss with you related to the ocean thermal conversion. Again, that is a beautiful review done by a beautiful professors. And the third one, again the little review related battery energy storage. I think already our previous speaker given a lot of information on battery storage, but in that how the battery storage critical review happened, that is what I am going to discuss. Only these 3 paper I taken to share with you about the information. 3 papers are in the Elsevier and Springer, and I am very happy that very beautifully done a literature review. So wait, I will share a screen. Selva, now the screen shared, Selva?
Yeah, yes, sir. Yes, sir.
Okay, right. Okay. Okay. So the we will see the wave and tidal research view. Okay. So this is a review title paper, life cycle assessment. We call it as LCA on wave and tidal energy systems. A review of current methodological practice. This is published in MPDI, good journal in 2020, very recent publication. Zhang and team done the very beautiful survey on the life cycle assessment. It is very good because the different people done a literature review on another parameters, because we all academicians, we all know that how we are doing the literature survey. So in that literature survey, we thought that literature survey we will take some topic on wave energy, tidal energy, and do the analysis, but this is totally different. It is totally different, which I would like to explain you. LCA, we call it as LCA. That LCA assessment, how the last 10 years people done review on that. That is what it is discussed here. Very beautifully discussed. Review, they done the recent life cycle assessment studies on wave and tidal. That is a very important thing they done. So the stakeholders to understand the current status. See why, what is the reason they did this life cycle assessment? Because the forthcoming stakeholders to be understand the analysis, what is the life cycle assessment of the present research which is already executed. They done the assessment with respect to the ISO 14040 and 2006 and ISO 14044. These 2 quality mandate they taken for the analysis. So few of the selected studies, they call it as a very strict, they taken and done the analysis. Okay. So it is beautifully again, see how they started the review. No? So they started the literature review, which states that how, which all the database they done the research. Maybe Web of Science, Science Citation Index, Journal Database, Mediline, Russian Science, where all they collected the data and what keyword they done. This is what they given very beautifully in the paper, which are the keyword they searched to identify the paper related to tidal and paper related to wave. Got it? Okay. So this is the which I found it is good, interesting. From that they identified 100,214 references. with the search, they identify 1214 references. From that references, they gone through the 3 different, that is the study or peer-reviewed journal article for full conference paper, or wave or tidal energy or design for production of, like that. They again go for 3 different combination. Based on the 3 different combination, they finally come out with the conclusion of the 18 studies, among which 4 studies were about tidal current energy and 12 cases were about wave energy. This is what they come to the conclusion in the literature. We call it as the refining of the literature review, which most of our people missing there. Very beautifully they done. Say they done a beautiful 1300-400 papers. In that they come out with 20 to 30 papers. How they done the analysis, they given okay. So again they refine the review. This is a general information of the studies, wave and tidal energy. What is with respect to the life cycle assessment, what are the papers and which region, what is the installed capacity, capacity factor, and ISO standard, which standard they use. This is this generally we will do. Then they done the comparison. They done beautiful comparison that see the various analysis, no, turbine, different types of vertical axis turbine, different oscillating watch column, alternator, horizon, like that, tidal range. Based on that, how it is pictorially represented. This is about the theoretically, methodologically, which are the methods which is used. Based on the method, how the 1200 papers are categorized. That is what they done. Next, they done the with respect to the prototype. How many prototype related papers? 8. How many under development? 3. Proposed, commercialized, like that. Yes. This is one part. Then they come to the conclusion of the result. What is the result? Is the life cycle they given the result based on the life cycle inventory analysis. In the life cycle inventory analysis, they again gone for the 5 different category. Under that category, they done lot of work, which I not quoted here. One is data collection and data quality. Second, data calculation and energy flow, validation of data, relating of data to unit process, allocation of inputs and outputs. This is the 5 parameter they taken under life cycle inventory analysis. I told you already 1200 paper they done. Again they categories into the which all the papers done the analysis, data collection and quality, which all the paper done the validation of data, which all the paper done allocation of input. So based on that they come to the conclusion. Again they given the conclusion. This is the conclusion, and some data assumptions it is there or not. So final conclusion, they given that how it is calculated. So I told you 3, 4, 5, 7, 8 parameters. How these 8 parameters validate, which all the papers linked with validation of data, which all the papers linked with allocation input, which all the papers linked with energy flow association with the input. This is what it is done. In the result, they category into 2. One is the we already studied life cycle inventory analysis. Second, life cycle impact assessment they did. What is impact assessment? How based on the life cycle, how impacted it resulted, and this is assessment analysis studied. And one analysis again they compare with a lot of different methodology. They compared operation and maintenance, climate change, ozone depletion, and human toxicity, like that, different things, different reference. They compared all the things, and again, so this is what the second part they come to the conclusion. They done a critical discussion. I told you already, beautifully selected a paper. In that paper, they again come to the conclusion of in the result 2 category. In the result 2 category, again they consolidated and finally concluded that most of the current LCA practices on wave and tidal system are not commendably following the framework. The conclusion they given, ISO guidelines and requirement established by ISO for 14040, 14044, most of the people not followed. It is very dangerous. They given in the paper, very dangerous, because most means they not mentioned correctly, but most of the people not followed that. This is the because this will be the very helpful for the future. Tomorrow I want to start some wave and tidal. If I want to start, if I will go through this paper, 100% I will not immediately what my mind thought that I will go immediately with respect to the standard of ISO. Why? Because they given very clearly. I not the paper indicates lot of information. I not taken lot of analysis here. So they given very beautifully stating that because of not implementing ISO, what are all the problem they faced. So when new customers, new stakeholders, they want to go for immediately, with this statement itself, it clearly indicates we need to go 100%, we need to follow ISO standard. Second, critical discussion, conclusion, result of different LCA studies can only be effectively compared if conducted with same or similar methodological standards. Say they done, but they come to the conclusion, if the conducted with same, say they done some analysis, mathematical analysis to do the thing. Tomorrow, if you go for some other mathematical analysis, maybe some changes will be there. That is what they quoted. Third, little limitation they did, that it is beautiful that they given the limitation. ISO LCA does not take into account the temporary variability of the inventory data. Inventory data, fixed data only they taken. Temporary variable data, we all know about the inventory data, no? So that inventory data, if there is a temporary variable values will be there. That value not considered in the ISO. That is what they quoted as the limitations. So this is the conclusion of the first. Okay, so next we will go to the ocean thermal energy research view. We taken again review of research on the closed thermodynamic cycles of ocean thermal energy conversion, a review of current methodological practice. It is in the Elsewhere 2020. It is going to publish. It is in the review stage. It is this hats off to the again author. They come out. What they're planning to do. They again done a review on the closed thermodynamic cycle of ocean thermal energy conversion. We call it as OTEC. We call short in the OTEC. Review on research on closed thermodynamic cycle. What are the different cycles? What are all the different cycle which people presented their paper? That is what they are review. Then description of thermodynamic cycles with either pure or mixture working, different combination of working fluids, how many papers are there and how they contributed. That is what the thing. This is the two thing which they did. I will go through fast. So this is the different ranking cycles, review of the cycles with pure working fluid and their working fluid. This is the what are pure working fluid, based on the working fluid, what are the ranking cycles, conversion cycles. This is solar energy reheating. This is again from one papers. They consolidated all the papers together. This is solar boosted ocean thermal energy, combination of solar ocean thermal energy, geo ocean thermal energy conversion, geo energy thermal ocean energy thermal conversion. Again, this is R717 OTEC power cycle. This is R717, nothing but a high pure ammonia, which the used for the power cycle, which will automatically give the performance efficiency good. Double stage ranking cycle, two stage of ranking cycle will be there. The two stage of ranking cycle, one they used water stream ranking and organic ranking bottom cycles. OTEC power cycle with vapor ejector. This ejector will help us to expansion of the gas. That is what they used, the vapor ejector. Next, the same vapor they used liquid vapor ejector, another part which will give more little comfortable value. Then EP OTEC cycle. This is nothing but a liquid vapor ejector with the motive pump to improve the efficiency. They connected some motive pump is here to improve the efficiency. Injection power cycle, like in thermodynamics in our bike or car, we have injection. That injection power cycle they implemented here. Uhira cycle. Uhira cycle, what is Uhira cycle is nothing but again ammonia rich mixture initially heated and it split into two stage, vapor and liquid. So vapor and liquid, it is split into two stage. Then this cycle they call it as the performance thermal efficiency will increased in this cycle. Geo high cycle, again the same ammonia plus water mixture in the geo high cycle. The power cycle with absorption power cycle. So this is what the different cycles, power cycles, which already the papers are there. They come to the conclusion, to the limitation caused by the small water temperature difference, efficiency of the OTEC power generation system is generally low. This is the conclusion. So the conclusion is the overall efficiency of the OTEC power generation is generally low in comparison with around 10-15 very beautiful research. And what is the reason also they given? Because of the small water temperature difference. The thermal efficiency of the cycle can be improved by optimizing the cycle. They are given suggestion. We can improve the thermal efficiency by optimizing the cycle. Third conclusion, it is difficult to find a working fluid with all kind of good properties. They given the conclusion, difficult to find a working fluid with all kind of good properties. Tomorrow, if you want to change the properties, so what fluid already we are using, we don't know how it is going to react. That is the thing, practical application, how it will be reacted. And coming to the limitation, due to the limitation caused by small water temperature difference, the efficiency of OT system, extraordinary general, that we already discussed. Okay, right. We come to our third one, energy storage research view. Okay, again, this energy storage research view in elsewhere, review of energy storage types, application and recent developments. They done again, what are the energy storage technologies, including storage categorization, comparison are critically reviewed in this paper. They done the types of energy storages, categories beautifully. Categories, what are the categories? Comparison are critically reviewed in this review. Already our previous speaker given a lot of information on the energy storage. So all this energy storage, battery energy storage, chemical, thermochemical, compressed air, magnetic energy storage, hydrogen energy, this all the things they done the review on that, how it is done. And this is the specific power with respect to the specific energy, how the capacitors reacted and how the electromechanical batteries, where the batteries are placed like that. And coming to the type of energy storage, so they categories into type, comparison, type, application and category. Type, this is a type, electromechanical, this is a basic thing. Type you can go through later also, compressed air, flywheel, that is pumped hydro, magnetic, chemical and hydrogen. And application, general application, energy utilities, renewable energy, building and transportation. Category and comparison, technical performance, economics, advantage and disadvantage. And again, they done the analysis on energy density. They taken the paper, all the which paper, the paper which all the battery they used, with respect to that battery, what is the energy density? With respect to the lead acid, lithium and on, they done the analysis and coming to the beautiful conclusions. Then another efficiency and lifetime properties of some energy storage technologies. Supercapacitor, it is giving very good performance. Flywheel, lithium ion. So this is in the top efficiency part, which is giving with respect to the discharge cycle, charging, discharging cycles. That is very important in the battery. When we go for the even our mobile phone, no, I will tell one example in the mobile phone. Our battery, we are having our mobile charger. If you go for charging and discharging of that your battery mobile, so within 2 days, 3 days, you know that what is your charging time of battery and what is your recharging time of battery. With respect to that, you can go for switching on the charging. Suppose your charging and discharging time, charging time is 3 hours. Charging time is 3 hours for your mobile, then you can switch on the mobile in the morning. If your charging time is 7 hours, then you can switch on the mobile in the night. So like that, the charging time and discharging time is very important for the performance of the battery. Based on that performance, they done that. So this is analysis already done by the researchers. They given the conclusion. This is a type of the energy storage with respect to category pumped. With respect, see, only this part only we last they given the category. Now they extracted to from electromechanical and battery, capacitor and battery, from capacitor, electrostatic, different types are there. That all you can go through later. Coming to the conclusion, among the energy storage types, much research is ongoing into various aspects of electrochemical research, energy storage. That is the conclusion. We know already electrochemical energy storage, most of the research is going on. Focus on introducing new storage material and understanding their applicability to several energy storage needs. A lot of researchers focus on implementing the new storage material to improve the performance. That is what the people are. And other electrical energy storage types such as flywheel energy storage, used for very short storage period, and frequent use, and magnetic energy storage have received less attention. And now the recently hydrogen energy storage system appear to be one that can result in large change to the current energy system. People are now talking about the hydrogen energy storage. Okay, so coming to the conclusion that hydrogen and electricity as energy carrier in the future, they concluded with both be improved as more renewable energy system are integrated with energy storage. This is a conclusion they give. So I hope I just run through all the things, because there is when you talk about the research, a lot of research already done, but particularly I not pinpointed inside the part. So when we go through these three important papers, tomorrow any students or faculty members can able to know the reason, what is the review which is done in the batteries, done in the ocean thermal, done in the tidal and wave energy. Thank you, Selva. Thank you.
Thank you. Thanks a lot, sir, for your session. Definitely that session has given an insights of what's the research, which direction which is going on. Durai, any questions from YouTube?
No, sir. No questions.
Okay, fine. So probably let me invite now Jones to give a overall conclusion. Jones? Yes, Jones, please.
Sir. So thank you very much, sir. Thank you for your wonderful session on the research view on the other renewable energy sources. All the three things, that is the tidal wave energy and the ocean thermal energy and the energy storage research views are excellent. I think I understand that participants gain more knowledge on this research views, sir. And I hope that you have clearly gave an idea how to do research on these three areas, and what are the parameters and standards to be monitored while we are doing the research, sir. I hope this session will be an eye-opening session for the budding researchers to start their research on this aspect, sir. Thank you very much for your wonderful session, sir. Thank you, sir.
Thanks a lot, Jones. Now we have an eminent speaker and final chief guest has joined with us. Sir, probably Ramesh sir, I think Lavanya madam got disconnected for some reasons. Can you introduce our chief guest?
It is very great opportunity again for me to introduce our chief guest. Pandian sir and we are connected together for last 20 years, and it was very happy from started from the basic career. We are together like a friends. Only the age is the difference, but like a friends. Connected with a lot of other society activities. Finally, now sir is our big mentor for us. Connected, he is the honorary president in the IGEN, and he is the mentor, senior mentor in our Green 9. And very happy to welcome our today's chief guest, Dr. G. Pandian sir, Senior Manager, Indian Oil Corporation, Chennai. And sir having very good experience in professional society activities. That is what it is very important, because sir in the IEA, he traveled a lot of activities in the IEA, and he traveled a lot of activities in the Institution of Engineering and Technology. We call it as IET. He was the chairman. Under his chairman period, very beautifully, IET developed very strongly in Chennai. So when he is the Chennai network chairman, his period for 2-3 years, and again he is the vice chairman. The student chapter is initially started with 5. Finally, it went on increased to 55. Enormous 55, and the student members, around 30,000 student members under his leadership. That IET got successful. That kind of leadership where Pandian sir is there. I am very happy, sir, very happy to welcome you to deliver the valedictory address, sir. Welcome, sir.
Yes, sir, you can go ahead, sir. Pandian sir.
Pandian sir.
Sir is connected. He's not muted. Sir, you can go ahead, sir.
Pandian sir, you can talk, sir. Be introduced. So, which numbers, which name it is connected, sir?
Galaxy M40, sir. He has joined from mobile.
Okay, it is there only. Okay.
Yeah, yes.
I
He's
think
on.
sir in mute.
No, sir, he's not muted.
Galaxy M40 is
No, sir,
okay.
no.
Sir, Pandian sir, you can talk, sir. Pandian sir. Pandian sir. Selva, I will connect, sir.
Yeah, okay, sir.
Possible, I will ask sir to talk in the mobile so that I can put it here, no? It will be okay, no? Voice will be there, no?
Yes, sir. Yes, yes, sir.
Pandin sir, உங்க நீங்க கனெக்டட்ல தான் இருக்கு. நீங்க பேசலாம் சார் இப்போ. ஹலோ. Pandian sir.
I think sir has to unmute and talk. I am unmuting him, but not. Previously, he was not muted. Now I think he has muted himself.
I'm wait, Salva. I'm trying in phone. If sir will take phone, then.
Yes, sir. Yes, sir. Actually, I think he has got disconnected from the call as well. You can connect him over the phone, sir.
Pandit sir, நீங்க போன்லயே பேசுங்க. நான் உங்க வாய்ஸை இதுல இது பண்ணிடுறேன். ஆமா, இந்த போன்லயே இதுல பேசினா போதும். நான் கொஞ்சம் வெயிட் பண்ணுங்க. கொஞ்சம் பேசுங்க சார்.
Hello.
Yes. Selva, it is audible?
Yes, sir. Little bit louder. Yes, sir.
Sir, கொஞ்சம் வாய்ஸ் சவுண்டா ஸ்டார்ட் பண்ணுங்க சார். Okay, sir.
Very good afternoon to all. Respected speakers, Dr. Ramesh, Dr. Palamurugan, Dr. Salukmar, and IGEN team members, and HOE EEE Department, Panimalar Institute of Technology, and the faculty members and participants. It gives me a great pleasure and honor to be part of this excellent and wonderful faculty development program on renewable energy resources, organized by IGEN and the Panimalar Institute of Technology. I would like to congratulate and appreciate the organizers, particularly Dr. Ramesh and his team and HOD EEE Department for taking initiative to organize this program in a great and a professional manner for the benefit of engineering community. It is a new subject included in the syllabus for engineering students in Anna University. Also, I would like to congratulate and thank all the speakers for their excellent and valuable presentation on renewable energy for the past 5 days. The content of the subjects on solar energy, wind energy, biomass, and geothermal energy were very informative, and I am sure that this presentation will be very useful to all participants, particularly for faculty members and the student community. I would like to mention the important point that every day the topic was presented by the experts in 4 aspects. In the sense, number 1, academic perspective, number 2, employment perspective, number 3, industrial perspective, and 4, research perspective. I take this opportunity to appeal all participants, particularly faculty members and research scholars and industry members, to connect with the IGEN and work for the green energy and the clean environment globally. I once again congratulate the organizers for organizing the excellent 5 days SDP program, and I would like to thank the speakers for the informative presentations, and also thank all the participants for the FDP program. Thank you very much.
Thanks a lot, sir. Thanks a lot. Your blessings mean quite a lot for us. Means what to say, we have just started and we are growing. And definitely your encouraging words means what to say, definitely ensure us to put some more efforts to reach great heights. Thanks, sir. Thanks a lot for your valuable things.
Thank you, sir. Thank you. Thank you.
Yes, sir. Yes, sir.
Thank you, sir. Thank you, sir.
Sir, Ramesh, sir, I'm going ahead with giving an overall conclusion for all the 5 days.
Okay,
Is that
okay.
fine?
Yes, sir. Yes,
Yes,
Selva.
yes, sir. Fine. Perfect, sir. Just a minute. I will put up my slides. I am going to give an overall view for 5 days. Probably I will start directly from day 1 and I'll put up a slide as well. Sorry for the little late. Yes. Yes, here it is. So I think it's a very good afternoon. So we have started 5 days back with quite a lot of energy, right? Because we have thought of discussing on the renewables, etc. It's an amazing task. I believe, I mean, so to say, 5 units of newly introduced topic, renewable energy systems, where most of the faculties have a very limited knowledge with respect to the practicals. They can at least take up some informations and they can teach from the theory what they are reading it from their books or in internet. But I mean, what to say, IGEN along with the Panimalar has thought in a different way. Why not means what to say, in addition to the subject, shall we convey some other real time, what's the project's experiences which the people have, shall we share that? So that these faculty members can go and teach their students not only from only for a theoretical perspective to get some marks, rather than understanding means what is going on in an industry, how to get a job, and how to do the research or for higher studies, how to make India or make in India. So means what say, many thoughts, many debates, many questions. You may not believe me, at least means what say, we had about last 20 days, every day evening around 7 to 8:30, we are discussing how to enrich this program. And finally, yes, the outcome was clear for the past 5 days. So we have started on Monday, where we have talked about the introduction of renewable resources. We have a great speaker, Dr. Sankar Narayanan sir, has inaugurated that function with his valuable thoughts and the policies. And day 1, we have introduced 4 different speakers from a different way. So on the renewable energy part, Arunachalam has given a really a good, very good theoretical content from the academic perspective. I am damn sure his notes and remarks, I can understand that he has at least put up about, 10-15 hours of effort in preparing that presentation. So we thank Sankar Narayan sir and Arunachalam sir, and the very important person, Bala Murugan, he is the man behind it, who was, brain behind this session or a show. So he has started this initiative. Why not we take, means in the sense IGEN take this initiative to start up an FDP faculty development program to bridge the gap between the industry and institute. So he has started it, he has worked passionately, and he has also delivered an important lecture on day 1 with an industry view of the renewables. And then we had an engineer, Senthil Kumar. He is always a man behind the show of all. So he has given the employment view on day 1 about the renewable. And our professor Elamis, I will come to him, but he has given the research view on day 1 on the basic renewables. And when we come to the day 2, means we have started day 2 is the wind energy conversion system. So we have started from engineer Sriraja Balakuru. He is from Tamil Nadu Tangetco, means generation company, government entity. So means what say, he has talked about, he has a quite vast knowledge on the wind energy conversion system. He is a man integrated all the wind energy in Tamil Nadu along with the grid. So he has talked about the employment view. And we had engineer Ramudas, he is manager power system studies at Power Projects. He has given the industry view of the wind energy conversion systems. And we had Dr. Uma Shankar from Prince Sultan University, Saudi. He has talked about the, academic view of the wind energy conversion system. Then we had Dr. N. Amudan, he has talked about the research view. So day 1 and day 2, probably if you look at day 1, we have an overall view of all the energy systems from all the 4 perspectives. And day 2, we have an exclusive view on the wind energy conversion system, where we have an employment view, industry view, academic view, and then finally the research view. Day 3 is a most important view because as I keep repeating, solar is growing exponentially. that's visible from the graph also. Means when somebody has put up some percentage, etc. You can go to the CEA website and look at in the past 3 years how much percentage the solar has grown. That's enormous. So day 3, we had an eminent speaker, Selvi Madam has talked about the academic view, and Engineer Balakumar has talked about the industry view, and he has also given an idea of how to simulate the solar plant design for a grid connected and standalone using a PVSys software. And I am assured that means at least part of the audience of this crowd has downloaded that software and has practiced it. Now they will be able to develop their own grid connected and standalone solar plants. Then I have given a little bit of employment view. And finally, Padmavati Madam has given the research view on the solar plant design. That is on day 3. So day 4, yesterday that we have started with N. Mahendran. So he has given the academic view of biomass and hydro. And Engineer Balraman, he has manager power systems at power projects. He has given a beautiful view of how to relate all this wind or solar or diesel or biomass and how to select what right capacity, etc. from the commercial perspective, correct? I believe, he's the one among the many speakers who has focused on the commercial aspect, just not a technical aspect. I think that's a different view which we have to really, faculties as well as the students has to look into. Of course, it is really important to get a green energy, clean energy, that's great, but at affordable cost, that is the most important thing. And I believe few of you have at least downloaded that software Homer and utilizing that. And finally, Mohan Sundaram has talked about research view on this biomass and hydro, where he has put up quite a lot of case studies in Kerala. And I have concluded with an employment view that's rather than an employment view, I have given some thrown lights of what's the skill the students and faculties has to develop if they want grants or if they want to enter into the industry or if they want to start themselves as an entrepreneur. Today, of course, that's an amazing session. I know the potential of these two important guys. They are working in a hardcore technology of energy storage. Mr. Yuvaraj, he's a deputy general manager at Schneider Electric. I believe, he has imagined actually when I have texted him back after his session, he told, I don't have any slides, but whatever I am talking was coming from, that's an emotional speech. Yes, that's the real reason why he has directly conveyed his thoughts to the, towards the heart of all the audience, those who have heard it. And he has listed out n number of companies. You may not be able to grasp all the companies on the first shot. So I request all of you to go back and listen to this YouTube video. Make a note of all the companies he has listed out, that all the plenty of companies providing an opportunity in this renewable sector. After Yuvraj, Rama Prabhu Madam has talked about the academic view of, this other renewable energy and energy storage. And Sivaguru means I can understand from the lot of questions from the YouTube as well as from the internal participants in Zoom. Yes, he was working, as I told, 15 plus years in the energy storage, 15 plus years in total, and out of which about 10 plus years in power electronic components, product development, and the last at least 10 years in the energy storage and microgrids. He has almost seen all the perspective of microgrid and energy storage systems. So that's the real reason why his slides are really inspired the audience, not only from the industry perspective, but also from the employment perspective and the research perspective. Finally, before going for a Ramesh sir, I will thank Pandian sir. Despite of his tight schedule and probably technology issues, he has joined through phone and he has expressed his gratitude to our program. Yes, this program is successful because of many legends behind us. So I thank all the speakers, all the chief guests, and all the peoples those who are behind working. There are many peoples those who have worked behind it. If I list a name, I could be at least 20. So many people have worked behind this session for a successful of the session. I thank everyone. And of course, last but not least, all the participants, those who have joined directly in YouTube continuously 5 days and almost 4 hours a day each day. Yes, I could see, sitting 4 hours in a continuous stretch is difficult. But despite of that, you have made the session wonderful. Without the audience, the session could not be grateful. Finally, I have to thank Dr. L. Ramesh sir for giving me this opportunity to take care of this entire 5 days. And of course, he's the man, who is just not running this one FTP. He is doing quite a lot of other activities, running IGEN, running Green 9. There are quite a lot of initiatives. I thought of giving an opportunity for him to share about his exposure on various other things which he is doing. But anyway, continuously following this YouTube channel will bring you quite a lot of other activities what you are doing. With that great note, I thank Dr. Ramesh sir as well for such a wonderful session. And I believe for our audience, the takeaways, yes, renewable is growing. renewable is exponentially growing. That's going to fetch quite a lot of jobs. That's going to give a quite a lot of entrepreneurial opportunity. Only question is, are we ready to put up our efforts to stand with the requirements? I believe this 5-day session has definitely given inspiration not only to the students, faculties, and research members, even the industry peoples, that they will be able to take up with the inputs what is provided in the past 5 days, and they will be able to better showcase in the industries or in the institutes, where they will the professors will be able to teach their students in a much better way. Students will be able to ask much better questions to their professors, and the industry peoples, those who have joined, will be able to design much better renewable sectors along with an energy storage. With that note, I will leave it back to Ramesh sir for his final concluding words. Ramesh sir.
Yes, yes, Selva. Selva, can you do one thing, Selva? In the YouTube, our energy saving campaign,
yes, sir.
The top viewed video is there. That you keep it ready. I will tell that time you can play. So that before that, I will tell about the campaign little bit. So people know that.
Yes, sir. Please go ahead.
Okay, so thank you, Selva, and we are coming to the conclusion note about Selva already given beautiful conclusion note about our FDP. So this is the idea which we planned. Yes, we successed in a good way, even though some improvement is there, that we will take care. All your suggestions, already a lot of participants given the suggestion. We'll take care of the improvement, take care all the suggestion, and do our review, and coming to the conclusion and the final steps towards the next FDP. Next FDP, any other institution, those who are interested, you can put an email to us so that we can come back to you with our committee approval. So that is one process. Second part, I would like to little about the Green Iron. Presently, the activities which going on is the Earth Day Energy Saving Campaign. It is going on. It started in April 16th. By a retired director of electricity board, inaugurated, and presently 325 participants registered, and 43 videos are telecasted in our YouTube channel. And before that, I would like to thank you all for subscribing our channel, because you were subscribed, and we know we got information from the subscription that who all participated. So that data also we collected. In the evening, we can collect the data so that we know that number of participants, and we will verify with the number of participants with the feedback form which you given. And thank you all. Keep stay in with us, because as Selva told, we are organizing a lot of green related activities, and which will come to you through our YouTube channel. That is one. And the energy conservation campaign I am talking about for the home energy conservation. You also now eligible, because June till July 10th, it is the last date for submission of the video. So it is available in our website. Go to the IGEN.org. The IGEN, THEIGEN.org. In that website, it is there, Save Energy campaign. Only thing you need to do, you have to take 4 minutes video on your interesting tips on how to save energy in your home. Yes, now you are ready to submit the video. After submitting the video, you have to do, we will give the telecasted link. That telecasted link you need to promote in a big way. Once you promoted 1,000, you are eligible for Earth Day award. Once you are promoted and get views of 5,000, you are eligible for a titled as Mr. Energy Champion, and you will be given 1 page in IGEN Book of Honor. And third one, when you reach more than 10,000 views, you will be designated as UN SDG, United Nations SDG Award 2020. Again, you can able to promote. This is what about this. So to crack the award, immediately join today the campaign and participate. And another campaign which is running with us is the bicycle day. We are celebrating that bicycle day. Only thing you need to, that also available in our website. Only thing you need to do, you have to take a bicycle, go for some 10 kilometer, 20 kilometer, tag it with your geotag, and submit to us. That also available there, and that will be given carbon credential certificate for you. So if you travel in a car for 7 kilometer, the same 7 kilometer, if you travel by cycle, you are saving 1 kilogram of CO2. So that is what the thing. So we will give carbon credential saving what you saved, that certificate. Not only that, lot of other environmental day we are going to celebrate in the month of July first week. One day full program it is going to come. Environmental day related conference or conclave it is going to schedule, and there is a 2-day event which is under energy saving club. We have 20 energy saving clubs in Tamil Nadu, Andhra, Kerala. Through that clubs we are going to organize 2-day event in the month of August. Day 1 7 hours, day 2 7 hours. The 2 days will be taken care by each college will be given 1 hour. Each college will be given 1 hour, and this club started with MGR, and now coming 15th we are going to inaugurate our club at St. Joseph College of Engineering, and I'm happy to note that next week we are going to inaugurate the club at Panimalar Engineering College. So going to inaugurate online. So this club also you can eligible to participate. All colleges are eligible. You can contact us later to start the club. So this 2-day event which we are planning in a big way, and the 2-day event will be end with the Green 9 Awards. So if you are ready, you are doing some green activities related to energy, yes, you are eligible for the awards. So this is what only some part only which I explained. We can see all the activities available at our website IGEN.org and green9.org. And moreover, which I would like to have is our membership for IGEN is going to open within a month. It will take a month. Our membership website page work is going on. So within a month, membership will be open. After that, you can apply for MIGEN designated degree, and FIGEN is there. Associate member AM IGEN is there, and honorary IGEN is membership is there, and innovation membership is there. Like that, lot of parts are there. So you can visit and be part, connect with us, because we are not asking you to connect with us to do something else. We are asking you to connect with us to we all collectively work together to make our environmental green. You know that now how pollution got reduced because of corona, right? But the same has to be continued with our technological development. So we don't want to stop with technology. Technology has whatever technology, let we allow the technology, but with that, how to reduce the pollution, how to reduce the pollution, how to recycle the waste products. This is what our work. How to go for conservation activities, both energy, cyber, whatever the conservation. This is what we are working. We want lot of volunteers like you come and join with us so that we can collectively make our environmental green. Because I told you already, we are connected with United Nations Sustainable Development Goal. Out of 17 goals, 9 goals we are working now in IGEN. In Green 9, 3 goals we are working. I think we are planning to give one video, which is the highlighted video. Now it is going on in our YouTube channel. Yes, Selva?
Yes, sir. Shall I go forward that video, sir?
Yes.
Yes, sir. I will share the screen. You just point out that video, sir. I will play that. I am already in our channel. This one now, sir. Earth Day. Hello, sir. Sir? Ramesh, sir, are you able to hear me?
Selva, open the Earth Day, Selva.
Inside Earth Day 2000. Yes, sir. In that
down views will go. Views is not visible here. Huh?
Yes, sir. When I am coming here, views are not visible. So.
Wait. No. This we can play this video. We support Save that from Nigeria. We can play this video.
We support Save Energy on Earth Day 2000.
That video.
Yes, sir. I will go ahead with the video, sir.
Selva, volume மட்டும் கொஞ்சம் வச்சிரு. செல்வா வால்யூம் கொஞ்சம் வச்சிருங்க. கேக்குது, ஆனா கொஞ்சம் வால்யூம் ஜாஸ்தி.
Yes. Just a minute. I think I am at full volume, sir.
Okay. This is the 9 mantras which Green 9 come out with concept after research. These 9 mantras, if today itself you can implement in your house, you can able to save 1 unit per day. We are guaranteed because it is a proved mantra which already we applied for 2,500 different style of houses and we got proved. We can apply and get benefit. 1 unit saved equal to which will be equal to what 700 liter of water. Which will be useful for the production of the thermal energy. So that is what we suggest to go for the our very little contribution to save 1 unit per day. That is what we are promoting. Yes, so this is like this. Around 45 videos are there in our Earth Day playlist. Go and watch all the videos. Not only that Earth Day play videos, we have Energathon videos are there. You can watch all the videos so that it will be have big beneficial for you. So we will connect you all through our membership within a month, and I request all to join. Today I will post our Telegram group. I request all the members to join in Telegram group initially because we don't want to have a lot of WhatsApp group. So once you all join in Telegram group, another 1 month or 2 months, we are going to close all the WhatsApp group. So we want all the members to first convert it to the Telegram group. If you are not having Telegram, you can install it. That is the best platform which we need to have all the connectivity through the Telegram. Initially, we are connecting to Telegram. Once our membership is ready, then we can connect you through our membership website. Thank you, Selva. Okay, thanks.
Thanks, sir. Thanks a lot, sir. Now we are almost at the close of the session. To formally propose a vote of thanks on behalf of Panimalar, I invite Rama Prabha madam. Rama Prabha madam, now you can close the session with the formal vote of thanks from Panimalar. Thank you, madam.
Thank you, sir. Thank you, Ramesh, sir, for your wonderful IGEN video with that. I thank Selva, sir, for giving me this opportunity. On behalf of IGEN and the Panimalar Institute of Technology, I thank everyone behind this FTP program with on-site and the off-site. Because in the background, so many people have worked with this. I thank everyone, each and everyone, because already Silva sir said there are so many people are there. We can't able to thank list out each and everyone. And overall, I thank everyone behind this FDP program. Actually, it is 5 days, a long travel. All the participants along with us 5 days. I'm very thankful for them also. And for the especially Ramesh sir and Bala sir and Silva sir and behind that Balraman sir, everyone, they have worked hard to bring this FDP as a great success. I think this is a very great success with the audience only. I thank especially all the audience, those who are connected with all the 5 days. Okay, thank you. Thank you very much once again, all the participants and the coordinators and the members behind this Thank you very much, sir.
Okay, Selva, நீங்க தான் ஸ்டாப் கொடுக்கணும் செல்வா.
Yes, sir.
Live stop பண்ணிரு.
Yes, sir. Fine. Thank you, sir.